ఆ? కనబడుతుంది కదా. అది మన యువర్ స్క్రీన్ షేర్ అయితే కనబడుతుంది కదా, షేరింగ్ అంటే హలో, అడిబిలిటీ ఉంది కదా అంటున్నా. హలో. Good evening, everyone. Everyone. Good evening. Okay. Yesterday, in our discussion, classification of systems we started. The first form of system we studied is linearity. Linearity means we observed we have to obey superposition principle. What is superposition principle? Sum of scaled inputs must produce a sum of scaled outputs. Then we consider the time invariant and variant system. What is the concept of time invariance? A delay in the input signal causes same delay in the output signal, means the considered system is an invariant system. What are the examples of variant system we checked there? Whenever the input or output is external function of time, it is a variant system. One possibility. Second possibility, modulator. Any signal multiplied by cos or sine function, modulation. That is another possibility. Time scaling operation is also variant operation. There we checked examples like when we try to connect two nonlinear systems or two time variant systems in series or cascade. Again, the answer, there is a chance of linearity as well as there is a chance of invariance. Let us move to the third system today's discussion, causal and non-causal system. Causal and non-causal. How we defined a causal signal? A signal that is defined for positive time. A signal that is defined for positive time is a causal signal. As it is system, it is relation between two different signals, input signal and output signal, which has a time dependency. What is causality of a system condition is present output should not depend on future inputs. What is the meaning of present output? Means suppose you want to check the output at a particular instant t0. Input may be taken at exactly t0 or less than that instant. It should not ask for any next instance like t0 plus 1, t0 plus 2. Present output is depending on future input, means it is a non-causal system that we cannot design practically. So whenever the present output depends only on present input and past inputs, then the system is causal. Present output is depending on future input, means it is a non-causal system that we cannot design practically. One general example I will give for non-causal system is, for understanding purpose, without releasing movie saying that it is bumper hit. It may happen or may not happen. Without releasing movie saying that it is bumper hit, may happen or may not happen. Without writing competitive exam saying that I will be in top 10. So that is prediction. With respect to feelings, so many things are possible. Reality is different. Most of you are aware. So non-causal systems cannot be designed. Non-causal systems cannot be. So how to give the definition of causality means a system is causal if the present output depends on present input, past values of the input. Present input and past values of the, it may be past values of the output also, but not on future inputs. So causal systems are said to be non-anticipative. Causal systems are said to be non-anticipative. Non-anticipation meaning is what, sir? They will never respond to future inputs. Okay? Be careful. As we vary time axis from minus infinity to plus infinity, At every instant, we have to hold this condition, sir. Even at one instant it fails means system is non-causal only. As you vary time from minus infinity to plus infinity. We are observing the parenthesis. Output time versus input time. We are not bothering about amplitudes here. Output time versus input time. Let me take one example here. Y of t equals to 3t plus 5 into x of t. Y of t equals to 3t plus 5 into x of t. This is the system. Is it causal or non-causal? What I mentioned with you, check output time versus input time. Parenthesis, bracket up. If I am substituting t plus 0, x of 0. If I am substituting t plus 1, y1 is x1. Instant of time is same only. System is causal. Don't bother about that extra multiplier 3t plus 5. We are checking output time versus input time. Be careful. Parenthesis is same. Y0, x0, y1, x1. Instant of time is same. System is causal. System is present output means we are speaking with time. Present input means that is also time. Past inputs, present input as well as past values of the input. Similarly, suppose we have taken a modulator xt into cos omega naught t. Now you think of, observe the parenthesis again. Output time versus input time, both are same or not? Y0 equals to x0, y1, x1. Instant of time is same or not? Don't bother about cos function. We are checking for instant of time. What is the system nature? Causal. System nature is whenever the output time, input time both are same, system is treated as causal. Sine of x of t. If you take system as sine of x of t. Now what we can say? Again, the instant of time is same or not? Again, the instant of time is y0 means sine of x0, y1 means sine of. So system is again causal. System is again instant of time is same. But if we modify the same expression, something like this, x of sine t. Instead of sine xt, what we have selected, sir? X of sine t. There is a chance for non-causality now. Why? What is sine t equals to 0? General solution. Sine t becomes 0 for which values of t, sir? All integer multiples of pi. All integer multiples of. If I am checking the output at minus pi, substitute here t place minus pi, what will happen to the bracket term? If I am substituting t place minus pi, what will happen to the bracket term? Output is checked at minus pi, but input is required at 0. Present output is asking for future input. Output is considered at minus pi. We are checking output at minus pi, but input is needed at 0. System is non-causal. Non-causal. System is present output depending on future input. In this example, the other instance may be, suppose if you want to check output at minus 2 pi, then also where we require the values are 0 or not. Because of the general solution of sine t, we are in a position to say the answer easily. Sine t means general integer multiples of pi or not. 0. Don't make the answer every instant as we vary time from minus infinity to plus infinity. At every instant, we have to hold our theoretical statement, not making the answer. One fellow mentioned a specific instant like t equals to 0. It is not according to your convenience, brother. At every instant. As you vary time axis from minus infinity to plus infinity, at every instant we have to hold the condition. Okay. In this case, it will fail at minus pi, minus 2 pi, minus 3 pi such instants. Present output means you are checking output at minus pi, but input is needed at 0. Future, non-causal. minus infinity to minus 2t x of tau d tau. Minus infinity to minus 2t x of tau d tau. Now you think integral minus infinity to minus 2t. The upper limit minus 2t is giving a hint for us. Upper limit minus 2t. Suppose I am checking this output at minus 1, sir. If I am checking output at minus 1, what will be the integration limits? Minus infinity to 2. I am substituting minus 1. We are checking output at minus 1, but input is needed till which instant? After integrating the input, we want input value till which instant? Till 2. System is non-causal. System is, if I am substituting output, if I am checking output at minus 1, t plus minus 1 means it becomes plus 2 or not. We are checking output at minus 1, input is needed till 2. Any negative value of t will make upper limit of integration as positive, means future. Suppose our upper limit is just t, minus infinity to t, then it is causal. Suppose the upper limit is minus infinity to t only, then the system becomes causal. If you take integral minus infinity to t, then the system becomes causal, sir. If you take integration limits from minus infinity to, then the system becomes, okay. If the upper limit of integration is t, then the system is causal. Two xn plus 3 into u of n plus 2. This is a discrete system. 2xn plus 3 into u of n plus 2. What we can think? 2xn plus 3 times u of n plus 2. If the upper limit is 2t also, same enjoyment. Output at 1 means input is still 2 or not. If the upper limit is 2t also gone. If I am checking output at 1, input is required till plus 2, then also gone. Think about this one, sir. 2xn plus 3 u of n plus 2. Output time, input time, both are one and same. System is causal. Don't bother about u of n plus 2. That is the additional signal added. Every one of us know it is unit step sequence where the samples are covered. The amplitude 3, sir. Just see our previous slide. A system is causal if the present output depends on present input and past values of the input. Whether we stated here, it also depends on external signals. So, in this example, we have to check the relation between output and input index. N means index, I will say. Okay. Y0 means X0. Y1 means X1. This is an extra signal that is added. Don't bother about it. System is causal. System is causal. Okay. This is additional signal added. Output index, input index, both are one and same. X of n square. X of n square. What you can say for x of n square? Think. X of n square. Non-causal. Why? Take some value. Y minus 1 means you are taking output sample at minus 1, input sample is needed at 1. Future. Y2. Then also we needed 4. Output at 2 is asking input at 4. Present output is asking for future value of the input or not. So system is non-causal, NC, non-causal. summation of input samples from N naught to N, summation of the input samples from N naught to N. N naught is finite number. N may be any value from minus infinity to infinity. We want to add the samples of the input from N naught to N. N naught is finite. N can be any number. N can be any number. It can be causal as well as non-causal, because whether the system acts like causal system or non-causal system, that is decided by N naught. Because we are saying N can have any chance, but N naught is finite or not. Suppose we have taken a possibility like N naught greater than N sir. N naught greater than, for your understanding, I am taking 3 and 2. 3 greater than 2. Obeyed or proof again for that? Okay. Funny thing. 3 is more than 2. What will happen to the expression? N place 2, substitute N place. N naught place, which number we have chosen? 3. 3 to 2 x of k. What is the series expansion now? x3 plus. Come on. Output is taken for which sample, sir? 2. Input is needed for next sample. Present output is asking for next sample. N naught greater than N means it is non-causal. Other way, what is the other possibility? N naught less than or equals to N, it becomes causal. N naught greater than N is non-causal. N naught less than or equals to N, it is causal. It is conditionally causal. Based on N naught only, we can say the answer. Based on N naught only, we can say the answer. You cannot say directly. You cannot say directly. When N naught is greater than N, it is non-causal. N naught less than or equals to N. For understanding purpose, I have taken an example here. N naught, we assumed as 3, N as 2, sir. What will happen to the expression? Y2 equals to sigma k equals to 3 to 2 x of k. Expand x3 plus x2. Output at 2 is asking for input at 3 means next sample, non-causal. What is other way, opposite way? N naught less than or equals to N, it is. When this type of question is framed in the exam, they will give the options very clearly for you. Under what value of N naught the system is causal or non-causal, because here we have both chances are not. Both possibilities are there. Suppose in this summation expression only, if I have made lower limit as 0, instead of N naught, I am taking 0. Upper limit N, 0 to N x of k. N can be again any value. N can be any value. Sigma k equals to 0 to N. Come on, sigma k equals to 0 to N x of k. Now, positive index, you will not face any problems. N is positive means you will not face any problem. Assume N value like -1. Sigma k equals to 0 to -1 x of k means x0 plus x of output is taken at -1, but input is needed for next sample or not. Output is taken at -1, input is needed for next sample. Causality is a compulsory requirement as you vary N from -infinity to +infinity, as you vary N from -infinity to +infinity. But here, what is the story? Positive index, we are not at all facing any problem. Positive index, but negative index, what happened? If I am checking output at -1, definitely we need the input at 0. Present sample is asking for next. What is the difference between previous question and this question? Here N naught is specific, but here any general index. Don't mix them. Previous example, n naught is specific some number, but here n can be any value. N can be any. Suppose if I change the lower limit as minus infinity instead of 0, if I make the lower limit as minus infinity, sir, minus infinity to n x of k, minus infinity to n x of k. This is the answer. Minus infinity to n x of k. We are starting at initial index minus infinity till n. We are starting at initial index minus infinity till n. So 100% it is causal. Let me clarify with an example. Suppose I substituted n plus 1, sir. Sigma minus infinity to 1 x of k. What is the expansion of the series? Etc. Because minus infinity we are not starting. Let us take few samples. X minus 2 plus x minus 1 plus x0 plus x of 1. We are checking output at 1. With respect to output at 1, all these are past inputs. This is present input or not. So present output is sum of past values of the input and present input. Present output is sum of past values of the input and present input. 100% causal system. 100%. Generally, we are calling this summation as accumulation. Accumulator means addition. What we are adding, sir? The past data is added to the present data. To give one real life example for accumulator, Normally, when you go to a supermarket, as we go on adding the items, in the bill generated, the bill that is going to be generated, the previous cost is added to the present value or not. So as you go on adding the number of items, the previous cost is added to the present value. Finally, what will get? Enjoyment bill. Correct or not? So accumulator job is what? In accumulator, the present output is combination of past inputs and present input. Okay. Suppose if I have Susan like this. M is some finite number. 1 by 2m plus 1 sigma minus m2 plus mx of n minus k. M is some finite number. How you think of 1 by 2m plus 1 sigma minus m2 plus mx of n minus k. Don't say m equals to 0 with the talent. If m is 0, yn is x, and what is the need of all this build up? Taking average, again, then again providing summation. As m is some finite number, I am assuming 1, sir. What will happen to the expression if I assume m plus 1? 1 by 3 sigma minus 1 to plus 1 x of n minus k. That is, substitute each value of k here, sir. X of n plus 1 plus x of n plus x of, where we have taken output nth sample, input is required for next sample, n plus 1 sample or not. So this system is non-causal. If m is 0, no need of this build up. It is a simple identity system. Yn is xn. What is the need of this average and minus m plus m variation? If m is 0, it is normal identity system. Yn equals to xn or not? Yn equals to x of n. This is actually called as moving average system. Moving average system. Why that word moving average system is, when you look at this expression, everyone see the cursor. When you look at this expression, n plus 1 sample, next sample n sample, next sample n minus 1. As we selected 3 samples, average 1 by 3. If you select 5 samples in the expansion, average becomes 1 by. It is acting like a low pass filter. That details will study later on, not immediately, where we are learning frequency domain. Okay, where we are learning frequency domain. Yn equals to y of n minus 1 plus xn. I have given a difference equation now for you. Difference equation. Difference. In this example, yn is the present output. Y of n minus 1 is what? Past output. X of n is what? Present. Because we are checking index. N means n minus 1 past, n is present. So 100% this system is what? Causal system or not? Respond. System is most of the examples, whatever I discussed here, maximum number, 90% of the problems are acting like non-causal type. But in the beginning only we said non-causal systems cannot be designed or not. Non-causal systems cannot be designed. What is the technique to convert a non-causal system to causal system means? What is the technique we are following to convert non-causal system to causal system means? There are two techniques. When you have infinite set of data, to make that as finite length, we are using a specific window. To make infinite set of data as finite set of data, we are using a specific window, FIR filters. Once we start the topic, you know what is the purpose of a window. Another way, suppose we have data from -3 to +3, sir. Assume a particular system has data from -3 to +3. If I cascade for that system minimum 3 delays, only idea, don't take that example emotionally, only for idea. Minimum 3 delays if you cascade. Z inverse is the symbol that we are using for delay, as I mentioned. Minimum 3 delays if you cascade, automatically it is causing right shift of 3 samples. So what will be the new index 0 to 6, where a non-causal system can be converted to causal system. So there are two approaches we are using to convert a non-causal system to causal system. One approach is windowing method. One approach is windowing method. To make infinite, when you have infinite data, to make finite set of data, multiply with a specific window. Other technique is normal shifting operation. Other technique is normal shifting operation. That many number of delays are minimum cascade. Because non-causal systems cannot be designed. Non-causal systems cannot be designed with the independent variable time. With respect to time, we cannot design the non-causal system. Continuous case T, discrete case N, TRN. Non-causal systems cannot be. Non-causal systems are also called as what? Anticipatory system. Anticipation. Causal systems are non-anticipative. Non-causal systems are anticipatory system. What about our brain, human brain or human body? Okay, certain times it will be causal, certain times it will be non-causal. Maximum non-causal only. Don't be tensed. Certain times, depending on the mood, it will behave like that. Okay. Well, that is about causality. So what is causality condition, sir? Present output depends on present input, past inputs, and past. Let me say mathematical. Causal system. Suppose if I am taking input xn, output y of n. Y of n must be function of. It must depend on what? Xn, x of n minus 1, x of n minus 2, etc. means past inputs as well as past outputs also, no problem. Y of n minus 1, y of n minus 2, y of n minus 3, etc. Whenever the present output, yn means present output, n is the same instant. It can depend on present input, past input as well as past outputs. That is causal system behavior. Let us discuss the fourth system, static system, also called as memoryless, and dynamic system. And dynamic means with memory. Static system and dynamic system. Static, memoryless, instantaneous, all have same meaning. Static, memoryless, instantaneous. Anticipation means expecting the future. That is meaning of anticipation. Causal systems, non-anticipation. What is opposite? Anticipation. So non-causal system means anticipation. What is a static system is, its target is very simple. Learn now, forget now. That is what static system. Learn now, forget now. No memory. So whenever the input and output behavior are observed at the same instant, it is static system. Suppose if we are checking output behavior at an instant 5, if input is also taken at 5, it is static system. If it is asking for past or future values, it becomes a dynamic system. So how to give the definition, sir? A system is static. A system is static if input and output are observed at the same instant t equals to t naught or n equals to n naught. Whenever the input and output behavior are observed at the same instant, then we can say it is static system. Otherwise, it is dynamic system. Suppose I have taken a system like this, e power minus 3t plus 1 into x of t. Is it static or dynamic? Again, what you have to check, sir? Parenthesis, output time versus input time, parenthesis, bracket, y0, x0, y1, x1, instant of time is same or not? Means static or memoryless. Static or memory. Input time, output time, they are one, and it is a static system. What happens if you take 3xt plus 5? What happens if you take 3xt plus 5? Again, instant of time is same or not? Means static system. y0, x0, y1, x1, instant of time is static system. What about modulator? Xt into cos omega naught t. Modulator. Again, the input time, output time, they are one, and system is ML means not my name. Memoryless shortcut I am saying. Static system is also called as what? Memoryless. Good. Some of you are answering. Y of t equals to d by dt of x of t. Y of t equals to d by dt of x of t. Rate of change means we are checking it a single instant or with a gap, sir. Any differential element is due to energy storing element, system is dynamic. Any differential element is due to energy storing element, system is dynamic. What are the well-known examples for you? Yesterday also we used a voltage across inductor, current through. L and C are energy storing elements or not? They are represented in differential form. Differentiation means it is due to energy storing element, system becomes a dynamic. Any differential element is due to energy storing element, system is rate of change means with certain gap. Good. Now you tell me g of n plus 3 into xn. G of n plus 3 into xn. Again, you have to check what? Output index versus input index. Y0, x0, y1, x1. System is what? Static. Y0, x0, y1, x1. Don't bother about the extra multiplier here. Don't bother about the extra multiplier. Now I have given decimation. X of 3n. X of 3n. Decimation. At 0, you will not face any problem. But what happens if I take y1 samples there? Output at 1 is asking for input at 3 or not? Output at 1 is asking for input at 3. Means what? Storage. Dynamic or not? D by dt xt is a causal system only. Don't be tensed up. I'm going to discuss the example at different places. Okay, d by dt xt is a causal system. I want to ask one question here. This first system is causal or non-causal? Everyone should say it. Present output depends on present input means causal system or not, sir? Causal. This second expression, see the cursor, everyone. Second expression is causal or not? Causal. This third expression, come on. It means all memoryless systems are Wood systems, causal systems. Once the system is static or memoryless, automatically it is causal. Some fellows, they cannot stop their emotion. Immediately they have put in the chat box. Don't get emotion when subject explanation is going on. Once let me complete. Not only me, any faculty. Still, if you have doubt, you can ask. Okay? Concentrate on the discussion that is going on. Friends. So conclusion is what, sir? All static systems or memoryless systems are causal. All static systems or memoryless systems are. Why we are saying that way? Causality also requires the same condition that present output should depend on present input. Causal case, it is past input also. Static system condition is present output should always depend on present input, means at the same instant, which is also a definite requirement for causality. The requirement is there or not? So once the system is static, automatically it is causal. Can you say vice versa? Gone. Causal system doesn't guarantee static nature. Let me go back to this accumulator problem. Present output depends on past inputs, and present output is combination of past inputs and present input. But it is storing the past data, means it is treated as which system? Dynamic. Don't say vice versa. Don't say vice versa. Gone. Once the system is static, automatically. Once the system is static, automatically it is causal, but not vice versa. But not vice versa. Let me give an example here. Good. Different differential equations are given for us, asked for three properties for us. By giving different differential equations, we have to check different properties. Linearity, time invariance, dynamic. I hope every one of you have recognized that all are dynamic. Why they are dynamic? Differentiation is there, so all are dynamic. Correct or not? All are dynamic. All systems dynamic because of differentiation. Let us discuss the other properties, sir. First expression is 2t dyt by dt plus 4yt is 2t xt. Whenever the input or output is externally function of time, we know, we have studied neatly that as variant system. It is a linear time variant, TV, time variant. Whenever the input or output is externally function of time, we say it is variant system or not. Of course, it is linear. No problem. How to check linearity for differential equation? First, you form one expression in terms of x1t, y1t. Keep it aside. Another expression in terms of x2t, y2t. Later on, xt plus x1t plus x2t, yt plus y1t plus. No problem. We discussed multiple examples on this concept. Linear time variant. Second expressions are linear time invariant. Almost the same example yesterday I have given for you. All coefficients are fixed or not? All coefficients are fixed. No non-linear element visible. No non-linear element visible. Linear time invariant, all coefficients are fixed. Think about the third one. 4 d square yt by dt square plus 2 into dyt by dt plus yt equals to 3 into d by dt. Again, all coefficients are fixed, means time invariant. No non-linear element visible for us. LTI system. No non-linear element visible. What is the last enjoyment? Dyt by dt whole square. Dyt by dt whole square means which elements are non-linear. 2t yt means external function of time. What is the answer? Time variant. Time variant. Good. Some of you are answering. Good, good. First system, coefficients are externally function of time. So time variant, no nonlinear element visible. Second and third expression, all coefficients are fixed with linear elements, so it is an LTI system. Third expression, dy/t by dt whole square means non-linear. 2t/t means time variant system. Coefficient function of time variant system. Simple question I'll give. We have given input as a rectangular pulse to some system. We don't know what is system. We define system with symbol what's that? Just a T. It is producing the output graph like this. It is producing output as another rectangle. Comment on its quality and the static or dynamism nature. Just I have given input output. Till now, we related y of t and x of t. Yt in terms of xt, different expressions we have taken. But now, input is a rectangle, output is also a rectangle. Only graphs I have given. We should comment on causality and static or dynamic nature. Comment on causality, static or dynamic nature. All non-causal or dynamic. Who is the creator? Brother, repeatedly I am saying signals and system don't show your unnecessary creativity. First class only I said don't show unnecessary creativity. Okay. There are certain conditions which are valid in forward way, not reverse way. This is not English subject active voice, passive voice. Repeatedly I am saying be careful. How to check causality? How to check causality here without knowing the system operation is simple. Before application of input, if output is not starting, system is causal. Input signal starting at which instant here, sir? 0. Output signal is also starting at 0. Input starts at 0, output starts at 0. Suppose in this graph, if I started the output at -1 gone. Before giving the input, output start means system is non-causal. In our question, before application of the input, output has not started, so system is causal system. It can start, output can start at 1, 2, 3, anywhere after 0, anywhere it can start. Before application of input, output should not occur. Before application of input, output should not. How to check that static or dynamism is, when you look at the graph, the shapes are identical, but their durations are different. Here rectangle, here also rectangle with some amplitude scaling. Shapes are looking like same, but their durations are different. Durations are different means shapes are same means which transfer may come into picture, time scaling or time shifting. Because what we learned in the beginning class, time scaling and time shifting are not affecting the shape, they are affecting the time axis or not. So duration of the input and output are not equal, length of input 2, length of output 3, but their shapes are same means possibility of time scaling and time shifting. So dynamic. Shapes are same, but lengths are different. Lengths or duration, these words I will use interchangeably, don't be tensed, but lengths are different. Dynamic. Possibility of which operations here? Maybe possibility of time scaling and still our competitive exam papers have not gone to this level. They may give just by giving input and output. If the question asked is whether it is causal or not, what is the point we have to observe, sir? Before application of input, output should not occur. Before application of input output is starting means system is non-causal. In this case, input started at 0, output may start at 0 or after 0, no problem. How to check? Dynamism. Shapes are looking like same. Shapes are looking like same, but their lengths are different. So maybe time scaling and time shift. Indirectly, we have to think what are the possible operations there. Indirectly, we have to think what are the possible operations there. Okay. Before applying the input, output should not before application of the input, if output is not existing, system is causal only. Before application of the input, if output is not existing, system is causal. I hope you have completed this. I'm going to the next one. Friends, make me happy by answering this discrete system. Asked for 3 properties here about linearity, time invariance, static or dynamic is the question. Static or dynamic. Think and answer me one by one. First expression, that matching you do, my job is only discussing the system properties. Okay, leave that build up. We are checking system properties. First expression is y of n plus 2 plus y of n plus 1 plus yn. Right sides are equals to 2x of n plus 1 plus xn. No non-linear element means linear. All coefficients are fixed, time invariant. Static or dynamic? Static or dynamic? N plus 2, n plus 1 are there means. So first expression is linear, time invariant. Study the second expression, sir. N square y square n plus yn equals to x square n. Y square x square means, come on, non-linear. Y square x square. Externally function of index n square means time variant. Static or dynamic, yn xn. Instant of time is same. So system is what? Memoryless. Y square x square is there, non-linear. Externally function of time index means time variant. That is the purpose of giving that statements. Whenever the input or output is externally function of time variant system. Okay. Instant of time is same, sir. So memoryless system. What is the third expression given? Y of n plus 1 plus nyn is 4nxn, linear, time variant. What is the reason? N into yn, 4n into time variant, linear, time variant. That indicates dynamic. Last bit, come on. Yn plus 1 into yn unknown signal product. Unknown signal product is which operation? Non-linear operation. Time invariant, time dynamic, time invariant, dynamic. This type of questions will be asked for you. Okay. Difference equation, right side the properties, In gate paper, they are habituated to, by giving one system, asking out of yes. I am audible now, friends. Generally, this type of models they will give. Okay. Yes. Everyone. Okay. Now we discussed 4 different forms of systems: linearity, time invariance, causality, non-causality, static, and let us go for the next system, that is stability. Stable and unstable system. The next system which we are learning is stable system. The concept of stability is based on boundedness. Boundedness represents the absolute value or maximum amplitude of the signal. Boundedness represents the absolute value or maximum amplitude of the signal. In time domain, we are dealing stability as BIBO, bounded input, bounded output. Bounded input, bounded. How to understand that word? Let me explain. We are taking system operation as a TT for a transformation. If the input is X of t, output is Y of t. Mathematically, we can say that if the absolute value of the input is taken as some finite number mx, which is less than infinity, if the absolute value of input is taken as some finite number mx, what is this mx? Suppose you have taken step function ut, amplitude 1. If you take same thing as 3 into ut, what is amplitude? 3. Some number, amplitude, absolute value. Then for the respect to system, if we make magnitude of the output also finite number, then the system is stable. Otherwise, it is unstable. Okay. So the point you should understand here is boundedness represents the absolute value or maximum amplitude of the signal. Maximum amplitude of the boundedness represents the absolute value or maximum amplitude of the signal. So you must be careful with this mathematical condition. Bounded input, bounded output, we are speaking in time domain. There are multiple forms of stability. Don't mix the words, sir. Asymptotic stability is one word. Marginal stability. Marginal stability we are using in control generally. What is the margin there? J omega x is the margin. J omega x is the margin. Okay. So you must be careful with respect to stability. You must be careful. Now we are dealing time domain stability, that is BIBO. A system is BIBO stable, BIBO. If for every bounded input, there exists bounded output. Yesterday only I discussed three systems have amplitude dependency. Which systems are? Linearity, stability, invertibility. Linearity we dealt with output amplitude versus input amplitude. Again, now stability means again output amplitude versus input amplitude. Okay, we are dealing with amplitude level. Let me observe which are the standard bounded inputs we are having. Can we treat UT as bounded input or not? Can we treat U of T as bounded input or not? Signal may extend over infinite length, but what is the maximum amplitude of UT, sir? One. Bounded input. Tick mark indicates it is a bounded. Can you treat impulse as bounded, sir? Continuous impulse. Jump. Why? Its amplitude is infinity. Can you treat ramp as bounded input? Can you treat ramp as bounded input? Gone. At infinite time, its amplitude is infinity or not? What about cos and sine function? What about cos and sine function? Their amplitude variation is plus or minus 1, but absolute amplitude is 1 or not? Amplitude variation is plus or minus 1, absolute value 1. Okay. So we can treat them as bounded input, cos and sine function. So in our discussion continuous case, as we are dealing with maximum standard test signals, U of T cos and sine function. Don't apply emotionally ramp as input and say system is unstable. What is the statement we have made? A system is BIBO stable if for every bounded input there exists a bounded output. Every. Why I have used? There are certain systems for which cos and sine function may produce finite amplitude as the output, but they may fail for step function. That is the reason for every bounded input there exists bounded output. For every, in discrete case, of course, both the inputs are maintaining finite amplitude only. Discrete case, both are maintaining finite amplitude only. U of n is 1. Boundedness is with respect to amplitude, not with respect to time index. Del of n is also maintaining finite. Discrete case, both standard signals we have learned, they are treated as bounded inputs. So boundedness represents the absolute value or maximum amplitude of the signal. Modulus means what is the maximum amplitude of that signal. So when you are checking stability, our y-axis output amplitude, x-axis input amplitude. When we are checking stability, y-axis output amplitude, x-axis input amplitude. So continuous system stability, if you want to check blindly, you can apply which as inputs are ut, cos and sine. Discrete case, both the standard inputs are maintaining finite amplitude level only. Both standard inputs. Let us discuss few examples here. If I have taken square y of t equals to x square t, is it stable or unstable? According to our previous slide, which are the bounded inputs? Ut, cos and sine. Ut whole square means again ut. 1 whole square is 1 or not? Cos square theta is 1 plus cos 2 theta by 2 finite. Sine square theta is 1 minus cos 2 theta by 2 finite amplitude. So any bounded input you apply for that system, any bounded you apply for that system, output is, if xt is u of t, output y of t is u square t. U square t means ut whole square is again u of t. Ut whole square is again u of system is you can apply any standard bounded input, 100% it is maintaining finite amplitude level only. 1 whole square becomes 1 whole square is. Alternative way of solving this problem is stability is linked to absolute value or not. Stability is linked to mod xt mod yt means absolute value or not. What happens if I take magnitude both sides for this system? Mod yt equals to mod xt whole square. Correct or not? Mod yt equals to mod xt. Just I am taking magnitude both sides. Our definite requirement is what, sir? Mod xt must be a finite quantity. I am not giving any input, but compulsory amplitude, maximum amplitude of input must be finite. Finite quantity whole square is finite or infinite? 2 whole square, 3 whole square, 5 whole square, any finite quantity whole square is. That way also we can say system is what? Stable. With input you can check, without input also you can check the stability. Here with input we verified, here without input we verified. System is think about the system t into x of t, t into x of t. Stable or unstable? Come on. T into x of t. If you have given that way, stable or unstable? What happens when you apply input as ut now, bounded input ut now? Output becomes t into ut, means it is a ramp function. Ramp function is bounded or unbounded, sir? System is a bounded input has produced unbounded output. U of t has finite amplitude, but ramp signal has at infinite time its amplitude is infinity, unstable. D by dt of x of t, d by dt of x of t, differentiator, stable or unstable? If you apply cos or sine function here, you will finite amplitude level if you apply cos or sine function here. But if you apply ut here, What is differentiation of step function, sir? Impulse. If you apply ut, differentiation of step is unbounded, means unstable. Actually, for this particular system only, I have used that word for every bounded input. If apply cos or sine function, what is our feeling? We may feel finite level, but it is failing for step function or not. So you must be careful. For every standard bounded input, we have, you must obey. Okay. There is a simple logic. If you feel this like a differential equation, see here everyone, see the cursor. If you feel this like a differential equation, whenever the input derivative is more than output derivative, automatically system is unstable. If input derivative dominates output derivative, automatically system is. In this example, what is the derivative of the input first order? dy dt means first. Output no derivative. If derivative dominates output derivative, system is unstable only. In any differential equation, if input derivative is more than output derivative, system is unstable. Suppose I have given right side d square by dt square of xt, gone. Then d also is unstable only. In a differential equation, if input derivative is more than output derivative, system. Think about integrator. Think about integrator. System is an integrator. Come on, sir. Tell me everyone, integration of step function is which function? When you are applying ut as input, integration of step function is ramp, which is unbounded or not? Done. When you try to apply ut as input, u of t as input, integral 0 to t 1 d tau, that becomes ramp, unstable. A bounded input has produced unbounded output. A bounded input has produced unbounded output. But in Laplace domain, what is the Laplace of integrator there? 1 by s. A simple Paulet origin means we are using the word marginally stable. So you must be careful. Time domain, we are using Bibo stability, BIBO, Bibo stability. Okay. As only two options are available, heroes simply saying that stable or unstable. One answer must be correct now. If I ask for linearity, non-linearity also yesterday, some fellows linear, some fellows non-linear. Only two options. One must be corrected. Think. Don't get emotion. Think properly and answer me. When we integrate step function, it becomes ramp, that is unbounded, means system is unstable, sir. What about a modulator? See here. Without solving, you can say. Suppose you applied ut as input. What is the meaning of cos omega naught t ut? Cos omega naught t ut means that oscillating signal covers only positive time with plus or minus 1 amplitude. Or you apply cos into cos square theta, no problem. Sin theta into cos theta also no problem. Every bounded input produces bounded. Mod yt is mod xt into cos omega naught t. I'm checking by modulus concept. Modulus of xt into modulus of cos. Anyway, absolute value of cos function is 1. Our definite requirement is mod xt must be finite. If mod xt is finite, automatically mod yt is what, sir? Finite. So system is, just I applied modulus both side. Mod yt equals to mod xt into cos. Mod ab style. Mod a into mod b. Absolute value of cos is 1. Mod xt is finite means automatically mod yt is also finite. System is in one of the exam paper, integration of modulator is given. So it is combination of previous two systems example. You can answer me. Integration of modulator. It is combination of previous two examples. Unstable system. Unstable. US means unstable. If I take modulus of yt, I'm checking by absolute concept because I already have checked the previous question. Integral x of t into cos omega naught t dt. But what is modulus of xt into cos omega naught t? We checked, sir. It is some finite number, something, some finite number. Even it is finite, integration is done for what limits? It may be 2 or 3, anything, finite. Even it is finite, integration is done from minus infinity to t. Answer becomes infinity. System is unstable. Even this quantity is finite. Integration limits are varied from minus infinity to t or not. Answer becomes infinity. System is unstable. System is unstable. Let us take few discrete systems. E power xn. Exponential operation I have given. E power xn. System is exponential operation. S or U. S for stable, U for unstable. S or U. Yeah. I have chosen another tool. Okay. Yn equals to e power xn is stable or unstable? Come on, sir. 100% stable system. Most of the fellows here, they may have a wrong thought of e power x curve. As x grows, e power x is growing. That is a wrong thought. This is not a time axis. Stability means what we are taking output amplitude versus input amplitude. This is not time axis. Be careful. X-axis is not time axis. Modulus of yn equals to e power modulus of xn. E power modulus of. Our definite condition is compulsory magnitude of the input is finite. E power finite number is a finite number. 100% system is e power finite value becomes 5. E power 1, e square, e cube, e power any finite number. Don't ask a stupid question if mod xn is infinity. Infinity is finite amplitude. So don't have this wrong thoughts. E power x curve. This is not time axis. Stability means output amplitude versus input amplitude. As long as input amplitude is finite, e power finite number becomes finite. System is stable. System is I am repeating the system that we studied at causality. Today's class only. Sigma n0 to nxk, n0 is finite. We want to add the samples of the input from n0 to n. Using bounded input, bounded output concept, you tell me, is it stable or unstable? The system is stable or unstable? Think and answer me. Sigma n0 to nxk. Good. Most of you are answering in the chat box. Good, good. For verifying stability of the summation terms. For verifying the stability of the summation terms, the easy technique is compulsory input amplitude must be finite. I am assuming 1. N0 is also finite. I am assuming 1, sir. Take your own assumption. No one will ask you. Okay. Input amplitude must be finite. I am assuming 1. N0 must be finite. Assuming 1. Then what will happen to that expression, sir? Y of n equals to sigma k equals to 1 to n 1. Input amplitude I have chosen as 1. N0 is 1. What is the expansion of the series, sir? 1 plus 1 plus 1. Like that, how many terms are there? N terms are there. 1 to n samples. Means answer is n. 1 to. What is the graph of n? Output graph is what? Instant of time is the respective amplitude. At 1 it is 1, 2 it is 2, 3 it is 3. Neatly it is looking like RAM sequence. Output graph. Yn is n is the answer we got. Yn is n. Bounded input we have given input amplitude finite, but we got unbounded output or not. As n tends to infinity, amplitude of output is tending to infinity. System is unstable. But what is stability requirements are? Even at infinite time, output should maintain finite amplitude level or not. Even you go for infinite index, output should maintain finite. A bounded input, xk is 1, bounded input has produced unbounded output. Don't ask a stupid question if n is finite. Who are you to control time? What you have to control? Amplitude level for stability, not time. Even at infinite time, amplitude must be finite. Even at infinite time, amplitude must be finite. That is paid. For solving summation examples for stability, this is easy approach. Again, you see here. Y of n is given as sigma n0 to n xk. For verifying it easily, what I have done, sir? N0 is a finite number. Input amplitude I assumed 1. N0 is 1. What happened to the summation? Sigma k equals to 1 to n 1. Once I start expanding the summation, each sample amplitude 1. 1 added for n terms means answer n. What is the general graph of n, sir? RAM sequence that is unbounded. RAM is unbounded. Bounded input has produced an unbounded output. System unstable. Okay. Slight modification in the summation I will make, think and answer. Slight modification. Y of n equals to sigma n minus n naught to n plus n naught xk. Again n naught is finite. Again n naught is finite. Think and answer me. Just I have modified the summation limits sigma n minus n naught to n plus n naught xk. Now we are varying summation from n minus n naught to n plus n naught xk. Follow our previous approach only, sir. This style only follow. Xk is 1 and naught is 1. Simple. Simple way. If I am taking xk equals to 1 and n naught equals to 1, what will happen to the system expression? Sigma k equals to n minus 1 to n plus 1, 1. N minus 1 to n plus 1. Correct? Everyone tell me. N minus 1 to n plus 1 means n minus 1, n plus 1 total. How many samples are there? 3 samples are there. 1 plus 1 plus 1. Every sample amplitude is 1, 3. Finite number or not? System is stable. System is stable. As I assumed n naught as 1, I got 3 number as output amplitude. If I assume n naught as 2, summation becomes n minus 2 to n plus 2, answer becomes 5. As long as n naught is finite, system is stable. In terms of n naught only, if you want output amplitudes are 2 n naught plus 1. See here everyone. N naught 1 means I got number 3 as the output amplitude or not. N naught 1. N naught 2 means I will get 5. Vary summation from n minus 2 to n plus 2. I will get the answer as 5. For solving summation problems in easy manner, either the previous question or this question, summation problems in easy manner, what is the best technique? Assume input amplitude finite number, easy number 1. N naught finite number, easy number 1. Here also we have done the same thing or not, such that we can check the stability easily. We can check the stability easily. Okay. That is a fifth system, stability, bounded input, bounded output, bounded input, bounded. Last system which we are discussing is called as invertible and inverse system. Invertible and inverse system. What is the concept of invertibility is, for a given system expression, if you are in a position to recover the input in unique manner, just by looking at the system expression, if you are in a position to recover the input in unique manner, then the system is stable. Then the system is invertible. The system is invertible. See here. A system is invertible if different inputs, meaning of different inputs is having different amplitudes. Having different amplitudes. Different inputs. This is also having amplitude dependency, sir. If I give +2 or -2, they are different only because their amplitudes are different. If I give a constant signal of amplitude 2 as one input, amplitude of -2 as another input, they are different only because their amplitudes are. A system is invertible if different inputs leads to different outputs. That is, two different inputs for a given system should not produce same output. Two different inputs for a given system should not produce. See here, we denoted system as a transformation T symbol. The inverse system is denoted as a T inverse. Input to the first system is X of T, output of the second system is X of T. Once you feel this system is invertible based on this theoretical statement, automatically you can find the inverse. If the system is non-invertible, inverse is not unique. Be careful. If the system is non-invertible, inverse is not. What is the output of first block, sir? Transformation of X of T. What is the output of second block? Simply X of T. Because T into T inverse denote an identity operator. Both the systems are opposite to each other. Wherever signal transmission is there, we are in need of using this concept. Wherever signal transmission is there, we are in need of using this concept. See, when you apply some form of input to the system, because of the internal components, it may get distorted. Because of the internal components, it may get. To cancel the distortion, we are designing the inverse block, which is generally called as equalizer in communication subject. Some of you are aware. To avoid inter-symbol interference, we are using raised cosine filter, zero forcing equalizer. Different forms of equalizers are not, sir. Tell me. So once we have decided this system is invertible, then you can find the inverse. If the system is a non-invertible system, there is no unique inverse. But first, let me explain what is the meaning of different amplitudes for different inputs, sir. Let me explain this point. Different inputs having different amplitude levels. If I am giving ut minus ut, they are considered to be different inputs only because their amplitudes are. If I give 2, 4, 5 or -2, -4, -5, I am changing amplitude level. They are different only. If I give R of t and minus R of t, this is also having amplitude dependency. This system is also having amplitude. All these are considered to be different inputs. Indirectly, if I apply UTR minus UT, if output is same, system is non-invertible. If I apply UTR minus UT, final output answer is same. System is. So a system is invertible if different inputs, in the sense different amplitudes leads to different outputs. That is, two different inputs for a given system should not produce same output. Two different inputs in the sense, for example, like if I apply UT minus UT, if you got same answer, gone. If you apply 5 and -5, if you got same answer, gone. Then the system is, for every standard input, we have to check this. For every standard input we are taking, we should check this condition. Okay. So invertibility also has amplitude dependency. Wherever signal transmission is there, that is linked to this concept, invertibility and inverse system concept. Because of the input signal you are giving to different system blocks. Once it got distorted, to cancel the distortion, we are designing the inverse block called as equalizer. We are designing the inverse block called as equalizer. Then only you will get the estimate of the signal. Then only you will get the estimate of the. Let us discuss few examples here. Y of t equals to x square t. Squarer is the system, whether it is invertible or non-invertible. Come on. squarer is the system. Is it invertible or non-invertible is my question. Think and answer me. Non-invertible. Because if I am giving ut as input, ut whole square is ut minus ut as input, then also what is the answer, sir? We changed amplitude of input, but output is same or not? Or if I give 4 and minus 4 constant everywhere, 4 and minus 4, then the output answer is 16. So system is non-invertible. System is, we changed the amplitude of the input, but output answer is same. We changed the amplitude of the input, but output answer is non-invertible. The other way of saying this point is, what is mathematically x of t in terms of yt? Plus or minus root? Plus root yt is correct or minus root yt is correct? Both are correct. In the process of choosing its inverse, you have sign ambiguity problem. If the system is invertible, inverse is unique. If the system is invertible, inverse is unique. But here plus root yt is correct, minus root yt is correct. That is other way of saying invertibility condition. If it is invertible, inverse is unique. But how many answers are there? Plus root yt correct, minus root yt also correct. Non-invertible. Similarly, you tell me modulus of xt. I am not writing. Mod xt. Non-invertible. Magnitude of positive or negative number is what? Positive only. Magnitude of positive or negative number is positive. Non-invertible system. Cos of x of t. Cos of x of t. How you think? Cos of x of t. Because of the periodicity of cos, inverse is not unique. Cos function periodically repeats for every 2 pi or not. If I give cos 2 pi as input, output is 1. Cos 4 pi, 1. Cos 6 pi, answer is 1. Because of its periodicity, gone. Cos inverse of yt solution is not unique. System is non-invertible. I changed the input cos 2 pi, cos 4 pi, cos 6 pi, 1. Or cos pi minus 1, cos 3 pi minus 1, cos pi minus 1, cos 3 pi. We are changing the input, output is same. E power j x of t, j for imaginary, e power j x of t. Check for the above inputs I applied. Check for the above inputs I applied. Again, you feel periodicity concept or not? E power j x of t, sir. Again, you feel e power j 2 pi. Substitute input place 2 pi. Output e power j 4 pi. Then also e power j 6 pi. Then also output is what? This system is also here and here we have periodicity concept, non-invertible system. Here and here we have periodicity concept, non-invertible system. D by dt of x of t. Differentiate d by dt of x of t. Think and answer me. Differentiation of any constant number is what? If I am go on changing the amplitude of input, differentiation of any constant is what, sir? One time I have taken amplitude 2, another time 5, another time 10. Differentiation of any constant is what? 0. Correct or not? Non-invertible. Every standard input we have to obey, sir. Certain functions, certain systems, it may be obeyed for UT. So that is the reason I am checking for UT and constant also. If it fails for one combination, automatically gone. U of xt. U of xt. Non-invertible. Everyone see the graph? Yesterday also we have done this. Output amplitude versus input amplitude. What is U of xt meaning, sir? For all positive inputs 1, for all negative inputs it is. You apply any negative amplitude of the input, output 0, any positive amplitude of the output. It means if I have chosen xt as 1, output 1. If I have chosen xt as 2, output is 1. If I have chosen input as 3, I am changing input, but output is fixed or not? Input like 1, 2, 3. But what is the fixed output from the graph? You have changed the input, but output is system is non-invertible. System is non-invertible. U of xt means it is 1 for xt greater than 0, 0 for xt less than 0. I have drawn the graph. Even if you change the amplitude of the input, output is fixed. But what is our target? Different input should produce us different outputs. It is gone. N into x of n. N into x of n. Discrete case, which are the standard inputs we can apply? Del n minus del n. If it is obeyed, un minus un. Okay. Suppose we applied input as del n, sir. What is the output answer? N into del n based on the product property of impulse. Impulse exists at 0, take the signal at 0. 0 into del n is what answer? 0, done. Minus del n also answer is product property of impulse. One time positive amplitude, another time negative amplitude we have given for the input, output is same 0. System is Ni non-invertible. System is this one. Signal multiplied by its shift delay. Signal multiplied by its delay. Simple logic here is, what is multiplication of two positive numbers? Positive. Two negative numbers? Positive. Gana. Two positive numbers positive, two negative numbers also. System is. Otherwise, if you want to check for a specific input, sir, suppose we are giving del n as input. What is the output answer you should write? Del n multiplied by del of n minus 3 jump means 0, because del n exists at origin, del of n minus 3 exists at 1. What is the product of these two samples? 0 or not? Minus del n also. Multiplication of two positive numbers or two negative numbers, answer is positive. System is non-invertible or not? Multiplication of two positive numbers are two Negative. Okay. X of n into sine 5 pi by 6 n. Signal multiplied by sine or cos function means we are treating that as modulator. Now, sir, xn into sine 5 pi by 6 n. Without solving, you can say, because in communication subject, from the modulated signal, if you want to get the demodulated signal, means recovering back our original message signal, do we have only one procedure? There are multiple approaches: coherent detection, non-coherent detection. These are the words we are using. Either you take AM or DSBSC, any waveform, there is no unique procedure to recover back our original message signal. So from the modulated signal to obtain the demodulated signal, we don't have unique technique. That way, without solving, system is non-invertible. Even if you solve that, bacha, what is there? Suppose we applied del n into sine 5 pi by 6 n. Del n into sine 5 pi by 6 n means product property. Impulse exists at 0, sine 0 into, then answer is what? 0. Even if you apply minus del n, again the answer is what? We have changed the amplitude of input, but output is same or not? System is. Before last year, this is asked in gate paper. 1 plus minus 1 whole power n xn. 1 plus minus 1 whole power n xn. In the question only hint is available. If I am taking only even samples of index, the answer is 2 times xn minus 1 whole square minus 1 whole. 0 for odd index. Means if I try to give any odd sample of the input, automatically what is the fixed output? 0 or not? If I try to give any odd sample of the input, output becomes. Tell me. One of my friend is asking, I think according to your example, there are very less number of invertible system. Yes, you are true. Yesterday only what I mentioned, 90% of the problems I'll give failure conditions only for you. Failure conditions only we'll discuss. Anyway, to give the answer, suppose I applied del of n minus 1, odd sample of the input, one time with positive amplitude, another time with negative amplitude. Both cases you are giving input for which sample n equals to 1. So it is not defined for automatically output is same or not. This itself has given indication. For odd value of input, any odd sample of the input, even you change the amplitude level, there is no use. Output is 0 or not. So system is non-invertible. System is. For even index, it is some answer. Odd index, it is 0. I have chosen a sample, odd sample. Don't bother about this amplitude value check. Whether I give plus del n minus 1 or minus del n minus 1, output is fixed. For odd index, what is the output answer? 0. You have changed the amplitude of input, but output is same. Y of t equals to continuous system. X of t minus 5. Shift by 5 units. y of t equals to x of t minus 5. Shift by. This is an invertible system because if I apply ut, I will get the output as u of t minus 5. If I apply minus ut, we are going to get the output as minus u of. If I give 2 constant for all time, shifted version also same thing. Minus 2 means minus 2. Or if I give ramp t minus 5 u of t minus. Every different form of input is producing different form of output or not, sir? Therefore, it is an invertible system. What is the inverse now? By looking at the system expression, if you want to recover x of t, by looking at the system expression, if you want to recover x of t, here in the output t is replaced as what? T plus 5. Original system delay by 5 units, opposite system is advanced by. Original system delay by 5 units, opposite system is advanced by. All different combinations of input is producing. In this particular example, even we change the amplitude of input, output amplitudes are also different. Invertible. As it is invertible, inverse is unique. Inverse is without solving this question, everyone should answer me. Decimation x of 2n. Decimation. We learned neatly one statement. Inverse of interpolation is decimation. Converse statement need not be true. From the decimated signal, we may not guarantee same interpolated signal or not. From the decimated signal, we may not guarantee same interpolated signal. Why? Zero interpolation we studied, step interpolation we studied, linear interpolation we studied. Inverse is not unique. Blindly, what is the answer? From the decimated signal, same interpolated signal is not guaranteed. If you want me to give an example, input 1, 2, 3, 4, I am taking one input. 1, 1, 3, 5, I am taking. Their amplitudes are different, sir. Their amplitudes are, what are they? 0, 1, 2, 3. Index 0. But with samples, they are retaining. Once you apply to decimator, here output is 1, 3. Here output is, no need of all this mathematical build-up. Decimation. Generally, from the decimated signal, we cannot guarantee same interpolated signal. This is a known point for us. From the decimated signal, we cannot guarantee same interpolated signal. Why? Zero interpolation, step interpolation, linear interpolation. Means inverse is not unique. With that logic only, you can say objective paper enjoyment is very easy if you are remembering this type of conditions. If whatever the theoretical conclusions I have given, you must be thorough. Even signal subject is mathematical, you must be thorough with the theoretical statement. Today we have used it. X of 2n is decimation. X of n is decimation. From the decimated signal, we cannot guarantee same interpolated signal because we have studied mathematically 3 forms of interpolation or not, sir? Tell me. Anyway, so out of the 6 systems we have studied, which systems have amplitude dependency, sir? Respond with me, everyone. Out of the 6 systems we have studied, which systems have amplitude dependency? Linearity, stability, invertibility. Linearity, stability, invertibility. Other 3 systems have only which dependency? Time dependency. Okay. Let us go for a short break. 20 minutes break. Short break. We'll continue our discussion. Short break you take. Yes, sir.
Hello.
Yes, tell me.
Yes, sir. Could you explain the last thing again because I missed that part? The y of n is equal to x of 2n. The solution which you wrote under that.
Y of n equals to
X of 2n. Yeah, the last thing, sir.
This is decimation, huh? 2n. X of 2n meaning is decimation or not?
Yes, sir.
Inverse of what we learned, inverse of interpolation is decimation. Opposite state need not be true. That is what we studied or not?
Yes, sir.
It means from the decimated signal, if you want to recover back our original signal as it is, there is no unique procedure. Nah? You can apply zero interpolation, you can apply step interpolation, you can apply linear interpolation. So there is no unique approach. So if the system is invertible, inverse must be unique, but three chances are there here. So for that, I have taken one example, simple example. I assumed four impulses of different amplitudes like this 1, 2, 3, 4, 1, 1, 3, 5. They are different only inputs. But this input are producing same output 1, 3. Picking alternating sample or not?
Yes, sir.
We changed input, output is same.
Okay.
Next.
Got it.
Hello. Bolo. Yes, sir.
My doubt is over, sir.
Next person I am asking. Hello.
Hello, sir.
Yes.
Sir, dynamic systems discussion తర్వాత ఒక ప్రాబ్లం చెప్పారు కదా సార్. x of t టైం డ్యూరేషన్ వచ్చేసి 0 to y of t టైం డ్యూరేషన్ 0 to 3, x of t amplitude 1, y of t. దానిలో మీరు ఒక స్టేట్మెంట్ చెప్పారు కదా సార్. ఆ షేప్స్ సేమ్ అండ్ లెన్స్ సార్.
Yes, sir. Tell me.
Shapes are same, lengths are different, so there is possibility of time scaling and time shifting అని చెప్పారు కదా సార్. అంటే మనం ఇప్పుడు y of t equal to 2x of 2/3t అని కంక్లూడ్ చేయలేమా సార్?
నేను మన థింకింగ్ లో ఇన్ అవర్ థింకింగ్ ఇట్ మే బి time scaling and time shifting. Some fellows will have different thinking, but definitely it is dynamic because duration of input and output are different. If even it is x of 2t/3 also dynamic only, na?
It is dynamic only, sir.
Even it is x of 2t/3, it is dynamic or not?
It is dynamic only, sir. What I am asking is, can we conclude y of t equal to 2x of 2/3t?
You may conclude, no problem.
Because you said there is possibility of time scaling and time shifting.
Yes.
You didn't say.
Yes, you can compress and shift the signal. What is there?
Yes, only there is
other possibility. There is other possibility.
There might be some other possibility also, sir.
Yes. Anyway,
so
time scaling and time shifting are, why you are thinking that way? Length of the input and output are different. I used a word possibility of time scaling and time shifting. Either it is time scaling or either it is shifting. In that case, both are dynamic operations only. Na?
Okay, sir. That part is clear, sir. Okay, sir. Thank you.
Yes, sir. Next. Hello.
Hello, sir.
Yes, ma'am.
Sir, in 48F slide.
1 minute.
Yeah. So in this slide, this u of x of t example is there, no, sir? In that, if we add another u of t, the system can be invertible, no, sir?
What?
In this u of x of t, this problem, if we add another u of t.
Listen.
Yeah.
Linearity, stability, or invertibility. Invertibility, you are taking y-axis as what? X-axis as what? Y-axis output amplitude, x-axis input amplitude.
Yes.
Even if you add extra function, it will not differ anything because I am changing the input Even the input amplitude is 1, I got output 1. Input 2 also, there are so many positive input amplitudes which I can change continuously, but still output is fixed, uninvertible.
Okay, okay. And another doubt, sir, 41F.
Hmm.
Yeah, sir. So in this problem, the fourth problem, D bit.
Hmm.
How is the system dynamic when y of n is there and x of n is there?
yn plus 1. N plus 1 is an example. It is not dynamic.
Okay, okay. And one more one. What are non-linear elements?
There are so many dead zone, backlash. If I draw the graph like this, it is non-linear. Diode is a non-linear element.
No, I mean in the problem, in the first problem, you told that there are no non-linear elements.
Linear elements in the sense like x square. Yesterday we studied unknown signal product, unknown signal division is non-linear, like that. Based on
Okay,
that conclusions only.
okay, sir. Okay. Thank you, sir.
Hello, sir.
Bolo sir.
Sir, I had a pretty different kind of doubt. In some questions, you're taking input signal as whole x of t,
Hmm.
and in some questions, you're taking input as n, like the internal one. That how do we know the difference between
Some
which
questions,
to
some
take
questions.
when?
Which example you tell me?
So the last question which we were doing, in that we were taking equal to.
Invertible inverse.
Yes, sir.
Which page? I think 48 or 40. What I have taken?
Not this, sir.
Here,
Yes,
I
yes, sir,
take
this one.
because it is invertible. First I have taken ut minus ut. Because it is obeyed, I have gone for other combination. As it is satisfied for ut minus ut. Previous cases, it is not satisfied for that function also. If
Yes,
because it is obeyed, it is making invertible for ut minus ut, I want to apply constant everywhere. Then also it is obeyed. Then I have gone for next standard function RAM. So for all different combinations, it is obeyed. Whereas in our previous examples, even for ut minus ut here failed. Correct or not?
Yes, sir.
So
How do we
and
differentiate
you have
which to take when?
to take means all standard inputs you go and apply here. Del T, ut, ramp, unless it is satisfied. Once it is failed, stop there.
Oh, okay, sir. Fine, sir. Thank you, sir.
Next. Yes.
Hello.
Yes.
Sir, it's Roshan. Sir, I just wanted to know means like here we are telling us that the different derivative is like ddt of xt is non-invertible. Sir,
Yeah.
but we can't say that its inverse does not exist. No, sir, because integrator
No,
would
there
be
is
an
no
inverse
unique
of
inverse.
different.
See the slide. See the. I can take inverse as integrator starting from 0 to t or minus infinity to t. You don't know what is its background, whether it is memory element or not. You don't know its past behavior. So there is no unique inverse. If
Okay.
the system is not having unique inverse, automatically it is non-inverse. Okay.
Okay, sir. Okay. Yes, sir. Okay. This was the doubt. Okay, sir. Thank you, sir. Thank you.
Enjoy. Let us continue the class doubt session in the ending again. Don't ask me any doubts in the ending again. Let me wait for another 2 minutes. Doubts in the ending. Okay. Please mute everyone. Any doubts in the ending, you can ask me. Till now, we discussed a total 6 different forms of systems, and the conclusion we have made is linearity, stability, invertibility, they have amplitude dependency, time invariant, causality, static or dynamism, they have time dependency. Let us conclude this topic with a very good example. See here, everyone. Oh, wait, is dancing, wait. Consider the feedback system shown in figure. Consider the feedback system shown in figure. Assume that output is 0 for negative index. Assume y of n is 0 for negative index. For this feedback system, when you apply first time impulse as input, del n. Every one of us know del n means it is occurring at 0 with amplitude 1. First time when you apply del n as input, what is the respective output for this system? Make a try, sir. A negative feedback system is given. First time we want to apply del of n as input. What is the respective output? Let us assume output of the summing point with symbol En. Output is feedback here with unity gain. Output is feedback with unity. Unit delay meaning is what, sir? Delay by one sample or not? Delay by one sample. So what is the relation between y of n and e of n? We can write y of n is e of n minus 1. Y of n is e of n minus 1. What is the relation between these three combination of the signals, sir? Xn minus yn is en. Xn minus yn is e of n. Remove the middle variable en. So as yn is e of n minus 1, you can say the answer is x of n minus 1 minus y of. The present output depends on past input and past output. Unit delay meaning is delay by one sample. Unit delay meaning is delay by one sample. The present output yn depends on past input and past output. X of n minus 1 minus y of. First, you find the system expression relation between input and output. We got this as the relation yn equals to x of n minus 1 minus y of n minus. As it is mentioned that output is 0 for negative index, we have to solve this difference equation starting from 0. First time, which input we are applying, sir? Xn is del n. Due to del n, first we are checking. Due to the first input, we are checking. If I substitute n equals to 0 in the difference equation, what will happen? Y0 is x minus 1 minus y minus 1. Input at minus 1 is not there, 0. Because input exists only at 0 or not. See the cursor. Discrete impulse exists only at y minus 1 from the given information is 0. What happens if you take n plus 1, sir, to that expression? Y1 equals to x0 minus. Everyone tell me, what is x0 sample? 1. Y0 is the past sample. Answer is, if you take n plus 2, y2 is x1 minus y1, x1 minus, so x1 input at 1 is 0, y1 is like that. Output is there for infinite length. Feedback leads to oscillations or not? Output is feedback to the, so output amplitude oscillates between 1 and minus 1. First sample, of course, 0, sir. First sample, of course. Rest of the samples are alternation of impulses. Rest of the samples are alternation of impulses. First, you find the difference equation describing the system. First, you find the difference equation describing the system. What I have done, I assumed output of summing point with symbol En. Unit delay means delay by one sample, such that this is the expression. See the cursor, yn equals to E of n minus 1. Output of summing point we denoted as En. What is the relation between these three combinations, sir? E of n equals to xn minus, remove the middle variable. As yn is E of n minus 1, this is the system expression it is forming. First time we applied discrete impulse as input, impulse at origin. Substitute 1 by 1 value here, starting from 0, because it is stated neatly in the question, output is 0 for negative index or not. First I substituted n place 0, what happens to the system expression? X minus 1 minus y minus 1, n place 0, sir. Input at minus 1 is not there, output at minus 1 from the given information 0. N place 1 means x0 minus y0, x0 is 1, y0 is past sample, like that. Till infinite samples you will get. Output is feedback to the input. Feedback leads to oscillations or not. The output amplitude oscillates between 1 minus 1, 1 minus 1, like that. First sample is 0. First sample is few samples you solve. Till infinite length it will be there. 1 or 2 samples you solve. The disadvantage of this question is solving this problem in time domain is the disadvantage. By giving this question only, suppose that fellow has asked find the output at 50th sample. Directly y of n at n equals to 50 mean, can you do all this enjoyment? Time waste or not? So what is the simple approach to be followed here? If you are failing in time domain, better to use transform domain. The fellows who are not aware of jet transform, don't be tensed. Just I am discussing the idea, alternative approach only. No tension. Don't take tension. Unit delay is represented as Z inverse symbol. Unit delay, Z inverse symbol. You can recognize this like controls are our electronic subject A, beta, GH, GH. What is the transfer function? If this is G, this is H, G by 1 plus GH concept or not? G by 1 plus. So I can write the transfer function of that system as Z inverse by 1 plus Z inverse. Z inverse by plus Z inverse. See the previous slide. This is Z inverse unity feedback. GH means G by 1 plus GH is for negative feedback system or not, sir? Z inverse by 1 plus. What is the input we applied? Impulse. Impulse Z transform. Sorry. Impulse Z transform is 1. Input Z transform also you take. This is nothing but output Z transform. For a discrete system, we are using Z transform concept for a discrete system. To write the inverse here, we have to use predefined things of Z transform. One is time shifting property. The other one, a predefined formula, A power n un is having Z transform as 1 by 1 minus AZ inverse. I am discussing only alternative technique. Don't be tensed. This discussion, once we start Z transform, then only you will know. By using these predefined formulas, we are in a position to write the answer directly. Everyone see again this previous slide, sir. It is a negative feedback system. Transfer function is like G by 1 plus GH controls logic. Or A beta means A by 1 plus A beta. Z inverse by 1 plus Z inverse. Input we applied as impulse Z transform 1. How to find out the inverse here is, y of n equals to, everyone this, see this formula, A power n un Z transform is 1 by 1 minus AZ inverse. So this is looking like 1 by 1 minus AZ inverse or not, but what is A number? Minus 1 whole power n un. Minus 1 whole power n un. A power n un style without this Z inverse. Rest of the term is 1 by 1 plus Z inverse or not, without this Z inverse in the numerator. What does that extra Z inverse indicates for us? Time shifting. Time, one sample of shift. One sample of, without this Z inverse, for 1 by 1 plus Z inverse based on this formula minus 1 whole power n un, it is causing one sample of shift. Everyone tell me what is the meaning of u of n minus 1? What is the meaning of u of n minus 1, sir? Signal starts after 1. Signal starts after 1. Signal starts after 1 means automatically what is the output value at 0? 0. In the previous slide, what is the answer we got? Output at 0 is 0. Suppose what is the output at 1? If I substitute n plus 1 here, minus 1 whole power 0 is 1. We got 1 or not? Output at 2 means, n plus 2 means minus 1. Same answer we got here or not, sir? So, to solve time domain way, it is very lengthy, but transform domain way, it is very easy. But in transform domain, if you want to answer the question, this background is needed, predefined formulas. Those who are not aware of these relations, don't be tensed. As we have to discuss. Just I want to discuss the disadvantage of time domain. If you want output sample at 50, substitute n plus 50 minus 1 whole power 49 means answer minus 1. Easily we got the answer or not? Easily we got the answer. See here, sir. Output Z transform is input Z transform multiplied by transfer function. Transfer function is Z inverse by 1 plus. First time we applied which has input? Impulse has input. Impulse Z transform 1 I have written. How to take inverse here? 1 by 1 plus Z inverse with A minus 1. 1 by 1 plus Z inverse A minus 1 means minus 1 whole power n un. Extra Z power minus n naught means in the signal one sample of shift. This u of n minus 1 indicates that signal starts after 1. Signal starts after. So to solve the previous, this particular question, rather than time domain, transform domain is easy. So the point you have to understand in this problem is, even solving a simple first order difference equation, in time domain is lengthy. Transform domain is easy. Transform domain is easy. This is time domain. This is transform domain. That is what I mentioned at periodicity for you. Graph to mathematical expression to graph. Time domain lengthy means I will go to transform. Transform domain, if I feel any difficulty, I will come back to time domain. Only technique. Okay? See, in this bit only, in this problem only, what is the second input we have given, sir? Un. Every one of us know what is un. 0 to infinity, every sample amplitude is 1 or not. You try on your own. In this case, the output must be alternation of 0 and 1. It is alternation of 0 and 1, sir. I am giving the answer for you. You try on your own alternation of 0 and please do for n equals to 3. Are you giving assignment, bacha? Giving me assignment. Y3 equals to x2 minus y2. What is there, bacha? When you apply del n, x2 is 0. What is y2 sample, previous sample? Minus of minus 1. What it will become? 1 only. Once recursive connection is there, feedback leads to oscillation. Feedback leads to oscillation. Second combination of input you try on your own. See here. This particular expression is called as IIR filter, infinite impulse response. Why that word is used means output contains how many number of samples here, sir? These are set of impulses or not? As you vary index from 0 to infinity. These are set of impulses. IIR filter means infinite impulse response filter. What is the basic difference between FIR system and IR system is whenever the present output depends on present input and past inputs only, xn, x of n minus 1, x of n minus 2, then it is treated as FIR system. See the cursor, if the present output also depends on past output, if the present output also depends on past outputs, then it is treated as an IIR system. Present output is combination of inputs only is FIR. If the present output also depends on past outputs, it is IIR. Nothing is there in controls. Open loop transfer function is like FIR for us. Here closed loop transfer function is like IIR filter for us. Okay. So the conclusion here is present output depends on present input and past inputs represents FIR filter, finite impulse response, FIR, finite impulse response. If it also depends on past outputs. What is the meaning of past output? Like y of n minus 1, y of n minus 2. It is treated as IIR filter, infinite impulse response. In this problem, we solved present output yn depends on past output also. It also depends on past output. It is called as infinite impulse response filter. Finite impulse response, infinite impulse response. Yn depends on x of n minus 1, x of n minus 2. Combination of only inputs is FIR. It also depends on past output means IIR system. So we solved by time domain, direct way, transform domain. If you have not understood, don't be tensed. All these relations I have to explain. The purpose of solving this particular problem is even solving this first order difference equation in time domain is lengthy. Time domain lengthy. Transform domain based on this mathematical background standard formulas. First we have written Z transform, single step we have written time domain answer. Background is what? Mathematical formulas. Mathematical. Present output means Yn. Present input means x of t. Discrete case x of n. Past input means x of n minus 1, x of n minus 2 like that. Then it is FIR system. Also past output means y of n minus 1, y of n minus 2, y of n minus 3 past samples of the output, then it is treated as IIR filter. Second input we applied in the same problem is UN. So you try on your own. You should get alternation of 0 and 1, sir. You should get alternation of 0 and 1. So whatever we discussed till this minute is introduction to signals and system, first chapter. Okay. Whatever we discussed till now, introduction to signals. What are the conclusion points? I prepared one handwritten notes. In few days, it is going to be uploaded for you. Don't be tense. After studying all these slides, what to remember means in it, I have written introduction in 2 by S. What are the final things you have to remember? Okay. In 1 or 2 days, it will be uploaded. I will inform the concerned member. Don't be tense. But study the notes. Then only you will understand the conclusions which I have given. Otherwise, emotion will be different. Okay. Recursive means present output depending on past output is recursive. Non-recursive means no feedback. Only combination of inputs, there is no feedback. That is non-recursive system. Recursive, non-recursive. Handwritten notes means conclusion. Why questions? How many questions you want? 200. Handwritten notes means conclusion. Yeah, review. What to remember? Conclusion. If you want more, I think they will provide volume 2 for you also. Apart from the models I am solving in the class, they may provide. Okay. Chodha, let us not deviate our discussion now. Let me start the next topic. Listen first. Don't write anything. Every one of you listen. Next topic is a linear time invariant system, also called as LSI system. Linear time invariant or linear shift invariant systems. LTA or LSI. LTA or LSI. Why we are giving more significance only for 2 systems, linearity and time invariance, when we studied till now 6 different forms of systems. Rough explanation, don't take emotionally. I'm giving rough explanation only now. Okay. Practically, suppose you have taken a series RLC circuit with some numbers. I'm not taking specifically numbers. This will form a second order differential equation which is linear as well as a time invariant. It will form a second order differential equation. An electrical system, or even if you go for spring mass damper, automobile suspension system is this only. Spring mass damper, a mechanical system. This is also obeying with fixed components, linearity and timing. An automobile suspension system contains the spring mass damper only. Okay. Either we design an electrical circuit or mechanical system, they are generally obeying which properties are linearity and time invariance. Most of the physical processes that are considered, they are satisfying both the properties. That is one reason we are taking LTI system separately. One reason. Second reason is we have chance of producing any signal as sum of impulses. First point of observation is an LTI system is always denoted with respect to impulse response with symbol h of t or h of n. Transform domain, you are always calling that as transfer function, sir. An LTI system is always represented with respect to impulse response. What is impulse response definition is, whenever the input is impulse, the respective output is named as impulse response. Listen. Listen. If I apply input as x of n to a general system T, we named the output as y of n, that is the transformation of x of n. When we apply del of n as the input, sir, impulse as input, whatever the output we are getting, that is called as impulse response. Transformation of del n. Transformation of del n. Okay. This is called as impulse. Input impulse, output impulse response. Input step function, output step response. If I apply step function, step response. If I apply ramp function, ramp response. Whatever the input you are applying, further what is the tag you are attaching? Response. Response is the tag we are attaching. Why an LTI system is represented only with respect to the word impulse response? Why you are not saying that as step response or ramp response? Let me discuss that point. Everyone see here, don't deviate. Input del n means what is the output? Now we have taken HN. Input impulse means output is, if I want to shift the input by some k samples, output is also shifted by k samples. Which property? Input delay, output delay means which property, sir? Time invariance property. If I am scaling the input by xk, output is also scaled by x of k. Alpha xn should give us alpha yn. That is what scaling property instead of alpha x of k, sir. Okay. If I am taking summation sigma term on the left side, if I am taking sigma term on the left side, automatically right side also we are taking what? Sigma. Doing addition is additivity principle. Doing addition means additivity principle. Additivity and scaling, they are combinedly called as which systems are? Linearity. Other property, time invariance, that is what our topic name are not. Additivity and scaling, they are called as linear. Other property, time invariance, that is what our heading. Whatever this left side expression we got, it is named as shifting property representing the input. Whatever the right side expression we got, that is output, which is a definition of convolution. Which is definition of left side expression is called as shifting property, right side expression is called as convolution definition. Why the word impulse response for this black box? Why the word impulse response for this black box is, according to shifting property, it is not shifting, shift, SIFT, sir. According to shifting property, the stupid summation formula says that any signal can be produced as combination of impulses. Any general signal can be produced as combination of impulses. How to understand that point? Let me give an example. Suppose if I have chosen this discrete signal, sir. If I have chosen this discrete signal, how many samples I have taken? 4 samples I have taken. What is the meaning of x of -1 into del of n plus 1? I am concentrating on the impulse that is occurring at -1 with amplitude 1 or not. See the previous slide. How I have written that term means, in this summation for the considered example now, k varies from -1 to 2. X -1 del of n plus 1. K place, see the cursor. K place -1 you substitute x -1 del of. K place 0 means what, sir? X0 del n or not? X0 into del n. What is the amplitude at origin, sir? 2. K place 1. K place 1 means x2 del of. What is the answer at 1? What is the last sample? x2 into del of n minus 2. At 2 it is. If I am adding these 4 individual impulses, we are recovering back our original signal or not. So any general signal, this is example, any general signal can be written as, sum of individual impulses. According to our previous formula, I varied in this question k from -1 to 2. I varied k from, in general, what is the range of k? If it is an infinite length signal, -infinity to +infinity. So as shifting property states that, any signal can be produced as combination of impulses. If you denote this black box as impulse response, you apply any form of input, it will cut the signal into pieces. What are the pieces? Impulses. It will find out the output due to every impulse internally to get the overall output. So if anyone asks you why an LTI system is represented as impulse response means, what is the immediate answer you have to say? According to shifting property, any signal can be taken as sum of impulses, which has given the thought of denoting this LTI system as impulse response. But we are not wasting our time by finding the output due to every impulse separately. At a stretch, we are getting the answer by this mathematical formula, which is named as convolution. Mathematically, we are in a position to know for a known input system, get the output. For a known input system, how to get the output means which tool we are using, sir? Convolution tool. Okay. So be careful. Why the word impulse response or transfer function means? According to shifting property, from this example you can understand. According to shifting property, any signal can be taken as what? Sum of individual impulses. That is the reason LTI system is always denoted with which symbols are impulse response, H of T or H of N. What is this convolution? Let me explain. What is this convolution? A general example I am giving, don't be tense. Suppose I placed some mass on a flat surface, particular mass on a flat surface, which is the system for us. What is the input to this? This one is hitting that mass continuously with a hammer. I am not that much artistic. Enjoy. You feel this like hammer. Hitting that mass continuously with a hammer. At every impulsive hit, you want to draw what is the graph, velocity versus time. To every impulsive hit, you want to draw what is the graph, roughly. If you make one hit, slightly this mass will move to a new position or not, sir. From initial to new position, like T0. Assume due to that impulsive hit, we got this graph, roughly. It's not exact graph. If you want to make one more hit, slightly it is going to new position or not. Slightly it is going to new position. Due to that impulsive hit, suppose you got the output like this. First one is like H of T0, first impulsive hit. Second one is like H of T1. If you want to hit one more time, it may go to another position, that is T2. Assume due to that we got like that. If you continue this experiment for 5 minutes, depending on your capacity, you may make 100 hits. Depending on your capacity. Due to that 100 impulsive hits, you draw the graph, the superposition of all these individual impulsive hits may form roughly the overall graph like this. Due to those impulsive hits, first we are taking individually the graph. After adding all of them, superposition of all those individual impulse responses, superposition means addition. Superposition of all those individual impulse responses may form a graph something like this. This shape we want, not the middle enjoyment. So how to understand convolution? Input here is hitting with hammer. System is what? Mass. What is output? We want to check the velocity versus time graph. So what is actually happening over 5 minutes duration means these are the things that are happening. At every impulse you hit, you are getting the graph. The superposition of all these individual impulse responses may form a new graph, something like this. Anyway, Chodo, it is a general example I have given. So our main concern is what? Come back to first slide. An LTI system is always represented with respect to impulse response. What is the reason for that? According to this property, what is the name? Shifting property. Any signal can be produced as combination of impulses. How we have understood that point from this example? Any signal can be produced as combination of impulses. That property has given the thought how to denote the black box as impulse response. Okay. Let me write that statement. Shifting property states that any signal can be produced as combination of impulses. Any signal can be produced as combination of. How we have understood this theoretical statement from this example or not? Here I have chosen x of n for 4 samples, which is actual addition of 4 individual impulses. What is the second point? Second point observation is LTA system is always represented with respect to impulse response. LTI system is always represented with respect to h of t continuous I am denoting. If input is impulse, what is the meaning of impulse response? If input is impulse, output is impulse response. If input is impulse, output is impulse response. Actually, why we got the second statement means because of the first statement. As a shifting property states that you can write any signal as sum of impulses, we got the thought of denoting the black box as impulse response. What is impulse response meaning? If you are doing experiment for 5 minutes, how many hits you have made? 100 impulsive hits you may make. How many impulsive hits you make, and you want to draw the graph. The superposition of all these individual impulse responses is forming the final output graph. Then what is this convolution tool? Why do we require convolution means? Convolution means it is a mathematical tool. By using convolution, we are finding ZSR, means zero state response. State means initial condition, zero state means all initial conditions are zero, sir. When we are performing convolution, we feel initial conditions are zero. By using convolution, we are finding zero state response of a system, to be specific of a LTI system, for a given input and system. For a given input and zero state response means with all initial conditions. See here, first I have explained here why LTI system is denoted as impulse response with this logic. Del n input, output name, Hn impulse response. If I delay the input by k samples, output delayed by k samples is called as time invariance principle. If I scale the input by xk, output is also scaled by xk, that is scaling principle. If I take summation on the left side, right side also we are taking summation. That is additivity principle. Additivity, scaling, they are combinedly called as linear system. Other property, time invariance, that is the topic name. But whatever this left side expression we got is called as shifting property. How to understand shifting properties, sir? In this example, I have chosen signal for 4 samples, which is actually addition of 4 individual impulses. That is what theoretically we have written. Shifting property states that any signal can be produced as combination of impulse. It is equally true for continuous case also. It is equally true for continuous case also. Then Why we are using convolution? That point I have to explain now mathematically with some examples. Okay. Observe the first slide. Why linearity and time invariance more significance is given means many of the physical processes we are using. It may be an electrical network or it may be spring mass damper mechanical system. Most of the physical processes we are using are satisfying both linearity and time invariance. Another reason is for any type of system, we want to give multiple inputs and we want to check multiple outputs. Sum of input signal should give us sum of output signals. Sum of inputs is sum of outputs. That concept is linearity. Maybe output is shifted version of input. Maybe output is shifted version of input. That concept is time invariance. Time. So to understand shifting property, this expression, we have chosen this example. In this example, I varied index from -1 to 2. In general, minus infinity to infinity. These are the theoretical points you have to remember, sir. Shifting property states that any signal can be represented as combination of impulses. LTI system is always represented with respect to impulse response. What is the definition of impulse response? Input impulse, output is called as impulse response. By using convolution, we are finding the zero state response. By using convolution, we are finding the zero state response. The zero state response of an LTI system for a given input and system. Zero state response meaning is all initial conditions zero. All initial conditions are zero. Relax. Textbook's overaction word is relax. LTI system means all initial conditions are zero. Let us concentrate on this word convolution. Let us concentrate on this word convolution. SIFT is a German word here. SIFT is a German word. They have invented this technique. Even we are saying convolution, but German it is Faltung. Not Faltu. Faltung. That is a word. They have invented the technique. That is the reason SIFT. Instead of SHIFT, they will use the word SIFT. German word. Don't be tensed for that. We are saying impulse, they say SIFT. Like that. Okay. Let us concentrate on this convolution. How to do convolution? How to do convolution? So I want to give a comparison table for you, both continuous and discrete convolution. I want to give a comparison table. From now onwards, what is the name of the system? LTI system. It is not general system. LTI system means what is the symbol we are following? H of t. H of discrete case, what is the symbol you will follow? H of input x of n, output y of, here input x of t, output y of what is that formula we derived here? Discrete case. This is a formula, not sir. Sigma x of k h of n minus k. Sigma x of k h of yn equals to xn convolved hn. This symbol is used for convolution, star operation. Okay, xn convolved hn, which is given by two relations. Sigma minus infinity to infinity x of k h of n minus k, or sigma x of n minus k hk. Convolution is commutative. Like AB equals to BA, xn convolved hn answer also equals to hn convolved. So both are valid relations. Sigma xk h of n minus k or sigma x of n minus k hk. Both are. What are the equivalent changes we have to make in continuous? Every one of you know. What are the changes we have to make? Come on, sir. Summation becomes integration. Instead of n, our variable is t. Like k, some other variable tau or not. Like k, some other variable tau. Integral minus infinity to infinity x of tau h of t minus tau d tau. See the notational changes I have done, sir. K place I use a tau symbol. Here n place I use a t symbol. Summation replaced as integration. Or other way, x of t minus tau h tau d tau. X of t minus tau h tau. As convolution is commutative operation, any relation we can use. Any relation. In the first slide, we observed how we got convolution formula in discrete. The same concept now we extended for continuous. Mathematical changes. What are the sequence of steps to be followed in convolution means? Depending on our convenience, any one signal must be folded first. Minus tau meaning is folding. Depending on our convenience, any one signal must be folded. Minus tau means later on the same signal must be shifted, sir. T minus tau. Later on the same signal must be shifted. T minus tau. After that, once you have h minus tau and h of t minus tau, h minus tau meaning is folding or flipping. Flip the coin. H minus tau is folding. T minus tau is shifting. Third step is multiplication. Multiply with other signal. Finally, to get the overall signal, integration. Depending on our convenience, any one signal is folded. Here I am giving example for h tau. H minus tau means folding. H of t minus tau means later on that signal is shifted. Multiplication, finally integration. Here integration means discrete case, what will happen? Summation. Here integration means discrete case, it becomes summation or not. Leave signal story, how to do convolution. Now I am explaining a very easy example. Every one of you will enjoy that. Easy example, known example for everyone. Okay. How we are actually doing convolution. Let me explain with one easy example. Suppose I have two second order polynomials like this. Quadratic. I want product of these two. Every one of you know normal enjoyment. How to get the product of the polynomials means, first we will multiply by s square some result. Next we multiply by 3s, shift result right by 1 unit like that. But I am solving this question now by convolution procedure. In convolution, what actually we are doing from the formula, one of the signal remains same. One of the signal remains same. Other signal must be folded and shifted or not. One signal x tau. If you see this formula x tau as it is, h minus tau, h of t minus tau we want. Here also, I am taking first polynomial as it is. I am taking first polynomial as it is. Take the folded version of second polynomial. This is like discrete data 1, 3, 4. What is the folded version of 1, 3, 4, sir? 4, 3, 1. I have done folding of second polynomial. First polynomial I kept as it is. Second polynomial is folded. After folding, start shifting. If I make this folded signal right shifted by 1 unit. If I make this folded signal right shifted by 1 unit, I got some overlap or not. Respond everyone. take the product and keep it aside. S square into S square is S power 4. S square into S square is S power 4. Take one more shift. Take one more shift. If you take one more shift again, we got overlap. What is that? S square into 3S. S square into 3S. 2S into S square. It is nothing but 5S cube. S square into 3S. 3S cube. 2S cube, sir. Take one more shift. Take one more shift. Again, you are going to get some overlap or not. Again, you are going to get some overlap. What is that? 4S square. 4 into S square. 4 into S square. 3S into 2S. 1 into S square. Add all the terms. 11S square. Add all the terms. Take one more shift S square out. Take one more shift S square out. Now 4 into 2S plus 1 into 3S. That becomes 11S. 4 into 2S plus 1 into. Take one more shift. 4 into 1. That becomes 4. 4 into. Correct. 4 into 1. That becomes. Take one more shift. That is also out or not. If I add all these terms, that is actually product of the polynomials. So here I have done folding and shifting of second polynomial. I kept the first polynomial P1 of S as it is or not. But the second polynomial is folded and shifted. In that process, whatever the output we got, this is convolution result. How convolution is different from multiplication means, in ordinary polynomial multiplication, you have multiplication of individual terms, addition, summation, everything is there. Only folding is not there. Only folding is not there. Why folding is needed means, there is a reason for that. Whatever the system we are designing, h of t impulse response, it should have maximum energy or power, because it has to detect the signal even in the noise environment. Our system has to detect the signal even in the noise environment. Indirectly, it must have maximum energy or power. When the system can have maximum energy or power means only when the first signal is folded, later on it is shifted. That is what we are learning. Matched filter as one of the application in communication. Matched filter, what is the system response we are learning, sir? Impulse response. Folded and shifted version of the pulse signal. Why do we need this maximum energy or power? At correlation, I will explain. Autocorrelation, cross correlation. Just for your understanding now, why folding is needed means, what is the answer? Why the first step is folding in convolution means, whatever the system we are designing, it has to detect the signal even in the noise environment. Indirectly, it must have maximum energy or power. When that system can have maximum energy or power means, when it can detect our signal means, when you first fold, later on shift the signal. Otherwise, convolution and multiplication both are. Sure, though, don't take serious about this example. But what is the theoretical statement you can make here? What is the theoretical statement we can make here is, I kept one polynomial as it is. The second polynomial is folded and shifted. I kept one polynomial as it is. The second polynomial is folded and shifted. So sliding one polynomial over the folded and shifted version of other polynomial is the concept of convolution. Sliding one polynomial over the folded and shifted version of other polynomial is the concept of convolution. We kept the first polynomial as it is, but the second polynomial is folded and shifted. In that process, wherever we have done multiplication, that is the overlap. Final output or not, that is a overlap. The same concept we are applying for signals also. The same concept. Everyone see my video, sir. See here, everyone. I'm giving a rough explanation. Assume this cell phone is like one signal. Of course, it is not a signal. X of t. My hand is the second signal. Assume it is folded. By keeping one signal as it is, what we are doing? By folding the second signal, you go on shift it. By keeping the second signal, you go on the folded signal. Assume my hand is the second signal which is folded. After that, go on shifting. Somewhere both are combined. Somewhere both are combined. That is what output result. First signal as it is, second signal folded. After that you slide. You slide the second folded and shifted version on this. In that process, wherever you got overlap, that is convolution. In that process, wherever you got overlap, that is convolution result. Is it clear? So how to give definition of convolution? Easy manner is sliding one signal over the folded and shifted version of other signal is the concept of convolution. Sliding one signal over the folded and shifted version of other signal is the concept of. From this example, we can make the conclusion, sir. We kept the first polynomial as it is, but the second polynomial is slided on the first polynomial by which operations? Folding and shifting. In that process, wherever we have done multiplication, final addition. Addition means continuous case integration. Addition means continuous case integration. Okay. First, everyone note down this theoretical statement first. Shifting property states that any signal can be produced as combination of impulses. What is the second observation, sir? Any LTI system is always represented with respect to impulse response. What is the meaning of impulse response? Whenever input is impulse, output is impulse response. And the last observation is by using convolution, we are finding what? Zero state response. Response means output. All initial conditions are zero for a given input and system. How to do convolution means these formulas we are applying. These formulas. I hope some understanding you got from this example. Everyone, some understanding. The same concept we are applying for signals. Don't take emotionally this example. It is not needed. Polynomial multiplication is not needed. This concept we are applying for signals by using these different steps: folding, shifting, multiplication, and integration. Convolution practical example. There are so many examples. When the signal is buried in noise, to detect the signal, we require it. Echo. Our signal transmitted after some time, it is retained at certain place with amplitude scaling xn plus alpha x of n minus 1 or x of n minus 2. That is linked to convolution. There are so many practical examples. Start of the chapter only, everything you want. Let me discuss here. What for we are learning convolution? First, let me explain the point. A chat box is available. Whatever you want, you will type. Okay. Polynomial once again. Okay. See here. One of our friend want from this only. Probably he loved this example. Okay. We want to take product of these two polynomial means general method. Every one of you knows, sir. First multiplying by s square, some answer will get. Next multiply by 3s, shift the result right by 1. But I want to get product of these two by following our convolution steps. What are the steps? Folding, shifting, multiplication, integration. 4-step procedure are that. So I kept the first polynomial as it is. What is the folded version of second polynomial? 1, 3, 4. 1, 3, 4. Fold it. 1, 3, 4 discrete data. If you feel like discrete data, 4, 3, 1. After folding, immediately we started shifting. See the cursor, everyone. If I make right shift of 1 unit, s square into s square, result s power 4. Keep it aside. Take one more shift. 3s into s square, 2s into s square addition. 3s into s square, 2s into s square, 5s cube. Take one more shift. Again, you do multiplication, add them. Take one more shift, s square out. 2s into 4 plus 3s into 1. Take one more shift. Whatever we got, this is output. The same concept now we are solving for signals problem. So theoretically, how to give convolution definition is sliding one signal over the folded and shifted version of other signal is the concept of convolution. Folding is needed to recover back our original message signal. We are designing a system or not. That system has to capture the signal. When it can pick the signal means indirectly it should have maximum energy or power. When the system can attain maximum energy or power means only when you first fold, later on shift the signal. This explanation is a matched filter example. Only in frequency domain I will give that clarity, correlation, comparison. There I will give clarity. Now you remember that folding is needed to provide maximum energy or power for the system. Why we are doing folding means that is the reason. Maximum energy or power for the system. I hope every one of you have taken these relations. First, I am solving models on continuous, few examples. Then we'll shift to discrete. First, I will explain graphical procedure, general method, then mathematical tricks. First, general graphical method I will explain one by one. Then, simple tricks. By using tricks also, we can solve the problem. Okay. Let me take one example. X of t equals to e power minus 3t ut. X of t equals to e power minus 3t. And h of t equals to u of t minus 4. Signal mathematical expressions are given. I have drawn the graph of them. Signal mathematical expressions are given. We have drawn the graph of them. Okay. Okay. What steps to be followed? Roughly we stated, depending on your convenience, one signal must be folded, later on shifted, multiply with other signal. But if you see this integration is done with respect to which variable, sir? Tau, to retain the answer in terms of t or not. Integration is done with respect to tau to retain answer in terms of t. Listen. Before following the steps, first step here is obtain the limits of output. Obtain the limits of output. It is a thumb rule. Thumb rule means without doing convolution, we are in a position to know. Without doing convolution, we are in a position to know for what time output is there. What is the thumb rule is? Sum of lower limits less than t less than sum of upper limits. Sum of lower limits less than t less than sum of upper limits. Everyone see the graph, sir. What is the lower limit of individual signals? 0 plus 4. Input signal xt starts at 0, h of t starts at 4. Less than t. What is sum of upper limits? Both are extended up to infinite time or not? Both are extended up to. It means from the first step it is confirmed that output is there only for what time? T greater than 4. Output is there only for t greater than. We can graphically show that for t less than 4 output is 0. We can graphically show that for t less than 4 output is 0. This is a thumb rule. Means reference. Without doing convolution only, we are in a position to know output graph is obtained for what interval without doing any convolution. Adding the lower limits, upper limits, bacha. First, you obtain the limits of output, adding the lower limit and upper limits of both the signals. Okay. Second step is change of axis from t to tau. What is the purpose of changing the axis, sir? Integration is done with respect to which variable? Tau, d tau. We have written d tau. Change of axis from t to. So it is not affecting the graph. This is x of tau with respect to tau. This is h of tau with respect to tau. It is not affecting the graph. We are changing the independent variable. Instead of the tau symbol, we use it. What for we have done? From the integration formula, it is done with respect to tau. Correct or not? Change of axis from t to tau. X of tau with respect to tau, h of tau with respect to. Are you solving with me? Convolution problem, you should solve with me. If you look at my face or slides, nothing will happen. Solve with me. Then only you'll get the idea. Okay? You must habituate. Now we will start our actual steps, which I have mentioned there. Folding. Folding also called as flipping. Folding other name. Which signal is easy to fold here, sir? Constant signal is easy to fold. Correct or not? So what is the folded version of that signal? 4 to infinity now becomes what? 4 to infinity now becomes what? Minus infinity to minus 4. 4 to infinity now becomes minus infinity to minus 4. Just flip it. 4 to infinity becomes minus infinity to minus 4. Depending on your convenience, you can fold any one signal. X tau, I want to take as it is. I folded H tau. I folded H tau. I hope you have completed folding. Because I folded H tau, I have to take shifted version of that signal. Next step is shifting. H of t minus tau. H of. From the folded signal, how to get the shifted signal means to the existing limits of folded signal, add the variable t. From the folded signal, how to get the shifted signal means, what are the folded signal limits here? Minus infinity to minus 4. For that, add the variable t. Add the variable t. Let me explain how we got the limits. What is the mathematical expression of h of t? Everyone see here, sir. Its amplitude is 1 for t greater than 4. Its amplitude is 1 for t greater than. So h of t is 1 for t greater than 4. So what is h of t minus tau? 1 for t minus tau greater than 4. t minus 4 greater than tau, tau less than t minus 4. Why we are expressing in terms of tau? Integration is done with respect to the variable tau or not? Less than t minus 4 means that itself is the upper limit. Who will do all this power action? Time waste or not? Don't waste your time. From the folded signal to get the shifted signal, what is the technique? To the existing limits of folded signal, add the variable t. What are the existing limits? See the cursor, everyone. Minus infinity to minus 4. For that, I have added t. Okay? Minus infinity to t. No need of all this stupid maths, sir. From the folded signal to get shifted signal to the existing limits of folded signal, add the variable t, add t. Minus infinity to minus 4, for that I have added t, minus infinity to t minus. In online class, this is the extra enjoyment I got. For your remembrance, I should write all theoretical statements also. One side shouting emotion, another side note downing all these points. With patience, I have to write. From the folded signal to get the shifted signal to the existing limits of folded signal, add the variable t, just for understanding. So minus infinity to minus 4, for that we added t, sir. Minus infinity plus t minus 4. Okay. Folding is over, shifting is over. What is the next step? Folding is over, shifting is over. The next step is what, sir? Come on. Multiplication. Which signals you want to multiply? X of tau and h of t minus tau. X of tau and h of t minus tau. Previous slide, x tau is there. Here, h of t minus tau is there or not? X tau and h of. How to do that multiplication? How to do that multiplication? See here. How to do that multiplication? What is the lower limit of x of tau? What is the lower limit of x tau? 0. But what is the upper limit of shifted signal? T minus 4. We want to slide the signal on x tau or not? We want to move h of t minus 2 on x tau. So how to start the problem is, assume in the first case the shifted signal has not entered the input signal. What is the meaning of not entering with respect to limits? T minus 4. Upper limit of shifted signal is what? T minus 4 less than 0. When you take t minus 4 less than 0, let us draw the graph, sir. What is the product of x tau and h of t minus tau? X of tau graph as it is or not? X of tau graph as it is. Shifted signal minus infinity to t minus 4. Just for understanding, I am taking other signal as dotted version. Whether this thick signal and dotted signal are combined for any interval, whether the thick signal and dotted signals are combined for any interval, sir, it means output is 0 for further simplified value of time as what? What is the simplified value of time, sir? T less than. First case, as we want to move h of t minus tau on the signal x of tau on the signal, we want to move it. What is our assumption? Assume the shifted signal has not entered the other signal. What is the meaning of not entering? With respect to limits, t minus 4 less than 0. Input starts at 0, shifted signal ends at t minus 4. T minus 4 less than, no output. Output is 0. Assume in the first case, t minus 4 is less than 0. What we checked in the first step, sir? Output is there only for what time? 4 to infinity. Yeah? Automatically for t less than 4, what is the output answer? Only cross checking. We know that. In the first step only, we know output is there after 4. This is cross verification or not? Tell me. What is the second possible case? What is the second possible case? You can enter this t minus 4 anywhere between 0 to infinity blindly. You can enter t minus 4 anywhere between 0 to infinity because it is a continuous signal. If it is discontinuous, we would have splitted the intervals. You can enter t minus 4 anywhere between 0 to infinity. So the second case is t minus 4 greater than 0. Then what is the product? T minus 4 greater than 0 means what is the product? Again, x2 remains same. Shifted signal extends from minus infinity to t minus 4. Now we are saying t minus 4 can be positive. Now we are saying t minus 4 can be. Now everyone tell me for what range of tau the thick signal and dotted signal are having overlap. For what range of tau the thick signal and dotted signal are having overlaps are 0 to t minus 4. This is the range of tau. This is the range of tau for which integrand is non-zero. This is the range of tau. See, I am entering t minus 4 over positive range 0 to. So t minus 4 greater than 0 means anywhere you can take 0 to infinity. So the thick signal and dotted signal are combined only for the range 0 to t minus 4. That is the range of tau for which the integrand is non-zero. That is the range of tau for which the integrand is non-zero. What is left? That stupid integration. Actual limits are minus infinity to infinity, but here we got overlap for what range? 0 to t minus 4. What is x2, sir? X of t is e power minus 3 tau u tau means what is x2 I have to write? E power minus 3 tau. H of t minus tau is this dotted signal or not? What is the amplitude of dotted signal for that interval? Enjoyment is integration. E power minus 3 tau by minus 3 over the limit 0 to t minus 4. X of tau is e power minus 3 tau u tau h of t minus 2 dotted signal. Simplification. So this is the answer valid for t greater than 4 or not. Second case is t minus 4 greater than 0 means t greater than. Inside the integral, substitute expressions of the signal. X tau into h of t minus 2. X tau is e power minus 3 tau u tau h of t minus 2 is dotted signal. These are the shaded portion or hatched area I have taken only for your understanding. Don't feel that itself is the area. Suppose our constant signal amplitude 2 here. We should take 2 here. Only for your understanding, I have taken that hatched area to know for what range of tau integrand is finite. This fellow started any shortcut. Wait, general method. First time explain general method. Everything you want shortcut. You will know how many shortcuts I will teach as time progresses. Are neatly just now I mentioned. First I will discuss graphical method, then we'll go for mathematical tricks. Same problem, maybe tomorrow or day after tomorrow class, in 30 seconds I will solve. It's a simple logic. Shortcuts will be there. First you learn the concept. Shortcut. Without concept, what shortcut? Our chip will be cut finally. First Always learn the general concept. That is most important, sir. It is my request. Shortcut will be there. I neatly mentioned I am explaining by graphical method, general method. Okay. Anyway, from case 1 and case 2, everyone look at the graphs of case 1 and case 2, sir. Case 1 and case 2, what is the point of observation? We have kept x of tau in its position as it is or not. We have kept x of tau in its position as it is, but we have moved that h of t minus tau dotted signal slightly in that process where you got overlap for t greater than. I'll show you some more points here. Suppose I want yt at t equals to 5. Output at 5. Then what is the product? X of tau into h of 5 minus tau. X tau as it is. What is the meaning of h of 5 minus tau, sir? Come on. Dotted signal, that is shifted signal, t plus 5 means it was 0 to 1 range or not. This portion we have to integrate. Same, suppose I want the output at t equals to 7. Then what will happen? X tau into h of 7 minus tau. X tau remains same. What is the meaning of h of 7 minus tau? Shifted version t plus 7 means shifted signal extends from minus infinity to 3. 7 place, sorry, t plus 7 means. So then what is the shaded portion? 0 to 3. If you want a particular instant also, you can solve. Output at 5 some portion, output at 6 some more portion, 7. By adding all those individual output amplitude levels, you are going to retain this type of graph, this expression. So we are not wasting our time by finding the output separately. At a stage we got the answer or not? By direct integration. This is the valid answer for t greater than 4 or not? This is the valid answer for t greater than 4. Anyway, we have written theoretically what is the definition of convolutions are. Sliding one signal over the folded and shifted version of other signal is the concept of convolution. In this problem, what we have done? On the signal x of tau, we moved h of t minus tau. On the signal x of tau, we moved h of t minus tau. In that process, we got overlap for t greater than 4 or not? Tell me. One more observation in this question is, everyone see here, sir. Input is a causal signal or not? It is there for positive time, causal. System is also causal. If you try to convolve two causal functions, causal signal convolved by causal signal means resultant is also causal, because output is there only for which time? After 4 or not? When we convolve two causal functions, resultant is also another causal function. Convolution of two causal signals is causal. Convolution of two causal signals is causal. Okay. Okay, we solved one model for today. Tomorrow I will discuss some more model. Okay, just for idea, I have solved. Depending on your convenience, one signal must be folded. Here, with signal, constant signal, we folded. For the folded signal only, how to get shifted signals are to the existing limits, add the variable t. After shifting, next our target is multiplication. With signals, we have to multiply in this problem x tau and h of t minus tau. First case, I assumed that shifted signal has not entered the other signal. T minus 4 less than 0, we did not get any overlap. Greater than 0, we got overlap. Here, for 1 or 2 instants, I explained generally. This is final answer after 4. If you want a specific instant also, you can take like this. Okay. For today, session class is over. Tomorrow we will continue. No homework questions. Are you solving really the questions which I have given yesterday. Everyone, only build up. Try to solve that questions. I'll give. As time progresses, one day I'll give 5-6 examples also. Be ready for that. Are you really solving, sir? Tell me. If you are really solving, very good. Okay. Okay, you can leave. Those who have doubts, stay back. Okay. All the best. Keep cool. Always your mind, don't be tensed. Regularly practice our lectures. Otherwise, it will be very difficult for you. I will always ask you what we, even after entering Fourier transform also, I will ask you what we learned in convolution or what we learned in introduction. Again, I will not explain signal graph, step function graph. This overaction I will not do, sir. Regularly practice. I think they are uploading regularly these notes. Okay. Very good. Very good. नहीं हुए, should work hard है, नहीं हुए बोले तो चालू करना है, अच्छे से पढ़ लो. Okay, I'll go to these notes, fellows. We have raised the hands. No doubts today. Oh, good. Very good. No one has raised the hand till now. Good. Ten minutes before only you are coming to class. Are you going to college? Hero? I think you are going to college. Yes, any doubts are there? Only in chat box they are giving. Option not enabled. Okay, I'll inform that fellow. What happened to him? Stay back, stay back. I am here only. Those who are having doubts.
Sir, ఇచ్చాను సార్ ఆప్షన్ ఇచ్చాను మీకు.
People are asking, sir. Okay. Yes, sir. Who is this?
Hello, good evening, sir.
Hello, sir.
Sir, there was a statement which you said that when we convolve two signals, like when exactly the two signals overlap, convolution output is high. So can you please elaborate that point using this example which you have given?
It's not high or low. It's not high or low. Where I said the word high? I have not said high. There is increase in the, see the last slide. Here, when I am checking at the beginning instant t equals to a certain portion area is there now. But when I have gone to 7, slightly increase in the area. means amplitude level may raise when you obtain that. Finally, here the output graph is a growing exponential or not. In this case, 1 minus exponential is roughly if you draw like this. Initially, it is amplitude is less, but in the ending, it is going to high level. Correct or not?
Yes, sir.
Yeah, that way. I have not used that word high or low. Just the range of tau for which the integrand is non-zero will increase.
Okay.
Next step.
That's it. Only one. Thank you, sir.
Right. Who is next?
Sir, good evening, sir.
Good evening. Good evening. Good evening.
Sir, I have doubt in yesterday's homework problem, sir.
What doubt? What doubt?
In signal 1, what is the value of x of t, sir? 1 or is it sin t?
X of t. Where have you been accepted? Okay. That full wave. Full wave rectifier.
Sir?
Full wave rectified sine wave.
Yes, sir. Yes, sir.
Sin pi t by 2 you have to take.
Sin
0 to 4 I have given. Sin pi t by 2 you take signal. It is not sin pi t. Because you should cover full cycle. Then only you can take it. Here it is half cycle means once it is passed through a non-linear device like mod x, then only it is generating full wave rectified.
Yes, sir.
Okay. Sin pi t by 2 you take, then only you will get the answer.
T naught value should be 2 now, sir.
T is 2 only. Fundamental grid is 2.
Then the signal 3 also, sir. I am not getting any idea.
What idea, ma? Neatly I have explained. This graph is combination. This graph is combination of rectangle and triangle. Day before yesterday, that type of example only I have given. Rectangular energy, triangular energy, 2 times product of these two.
Sir, that I did, but time period I have doubts, sir. 2, 5 they mentioned.
Time period is 5. For third signal, time period is 5, na?
Yes, sir.
Yes.
Okay, sir. Thank you, sir. Thank you very much.
Right. Who is next? Yes.
Good evening, sir.
Bolo, sir.
Sir, I have a doubt regarding the first homework question, sir.
What is the doubt?
Sir, in the first function, we have given triangular t minus 2 whole by 2 given, sir.
What is that?
Triangular function shifted and scaled by 2, t minus 2 by 2.
Study one more time.
Triangular function t minus 2 whole by 2, sir.
What is the doubt for you? Any amplitude is there? Just try before try anything.
Sir, 2 is there, sir. But my doubt is regarding sir, why it is not equal to t by 2 minus 1, sir.
You can write this way also. 2 try t by 2 minus 1 you can write. But scaling and shifting you should do properly, na? See, try t means what we learned minus 1 to 1 it covers with amplitude 1.
Yes, sir.
2 try t by 2 meaning is what, sir? Same triangle extends from minus 2 to 2 with amplitude of 2. 2 try t by 2. That is right shifted by 2 units. That is a required graph for you. 0 to 4 triangle covers. First you draw 2 try t by 2. This graph right shifted by 2 units.
Sir, right shifted by 2 units, sir.
Array 2 try t by 2. X of t equals to 2 try of t by 2. What is the meaning of x of t minus 2, sir? Directly t plus t minus 2 or not?
Yes, sir.
That is what this signal.
Okay, sir.
Next. Over.
Over, sir.
Enjoy.
And this.
Who is next? Bolo.
गुड इवनिंग सर.
बोलो सर.
क्वेश्चन ऑफ फीडबैक सिस्टम का जो क्वेश्चन था देखो फीडबैक
क्या है उसमें?
उसके अंदर वी हैव द नेगेटिव फीडबैक राइट. स्टिल वी आर गेटिंग oscillations. In analog I have studied that for positive feedback we get oscillation. So I'm getting a bit confused.
What confusion is there? It is oscillating where 1 minus 1 only. It is not going to infinite amplitude level. Feedback generally leads to oscillations. Where the output amplitude is oscillating here, in our case 1 minus 1. Even if we apply, even it is oscillating between 0 and 1 only. It is not going to infinitic level. It is not an unbounded signal, finally.
So in analog circuit, I have studied that
whatever it may be, feedback generally leads to oscillate. Where what oscillate means amplitude level is oscillating.
Okay. Yeah. Okay.
Oscillating means it's not you or me here. Amplitude. Here amplitudes are oscillating. Correct or not?
Yes, sir.
But they are not becoming unbounded level. They are finite level only. Output becomes stable signal only.
Okay. Is it stable? Okay.
Yn 0, 1, -1, 1, -1 is not stable. Yn has finite amplitude level.
Yeah, boundary.
Plus and -1 are not finite for you.
Yes, sir. Fine, sir. Thank you, sir.
अरे brother.
Got it, sir. Got it.
ग्राफ ड्रा करो ऐसा है ना 1, -1, 1, -1. Finite only output graph.
तो मतलब अनस्टेबल होने के लिए इन आउटपुट होना चाहिए.
अनबाउंडेड होना है, इनफाइनाइट एम्पलीट्यूड तक जाना है.
ओके.
और क्या है?
या रियली थैंक यू.
और क्या है?
नहीं बस हो गया सर, बस उतना ही.
हाँ एंजॉय करो. Carry on, carry on. Hello.
Hello.
Yes, sir.
The graphical method which you told of convolution, sir. Could you open that?
Yes, sir. What is the doubt?
Sir, I had a doubt means like after the folding which you told that shifting part, sir, we will not change the signal. Just we'll put T no in the location of the limits.
If I added T na.
Okay, nothing means no change to the signal.
Listen. Suppose I have given U minus T. U minus T negative time minus infinity to 0 na. U minus T signal means minus infinity to 0. If I say right shift of one unit, it will cover from minus infinity to 1. How shape will change? Only time axis differs. Here T stands for our first step limits. In this T minus 4, what is the range of T? We can vary actually in this question. 4 to infinity only output is there. Na? For T less than 4, what is the output we observed? Case 1. Output is 0 or not? Tell me.
Yes, sir. Yes, sir. The first thing is they are not overlapping.
Good.
Okay, sir. Okay, thank you.
Yes, sir.
Hello, sir. 45.
1 minute. Why multiples getting? Is it Sagar?
Yes, sir.
45.
Yes, sir.
1 minute. Hello, sir. Hello.
Sir, here in first example, actually it is unstable system.
कैसे?
E power any value if we substitute, then it will be unbounded, no, sir?
E power any value. What is that value? Xn represents amplitude or time? There X of n means input amplitude or time?
Time, sir.
Time? Xn means time?
No, sir, like amplitude.
Amplitude infinity कैसे ले सकते हो? Bounded input बोलते. What is the condition for stability? Try to apply input signal with some finite amplitude. Then how you can take Xn as infinity?
Okay, sir.
अरे ये तो इनपुट एम्पलीट्यूड है यार, वो टाइम एक्सिस नहीं है, इसीलिए यहाँ पे क्रॉस मार्क किया ना. वो टाइम एक्सिस नहीं है, इनपुट एम्पलीट्यूड है. इनपुट एम्पलीट्यूड मस्ट बी फाइनाइट रहना है. एक्सएन फाइनाइट हो तो ई पावर फाइनाइट ही होता. Most of the local textbooks they will use this as wrong answer. That explanation also will give weight. Most
like
of the local books they have done a blunder mistake here. I will explain that. हो गया?
Okay, sir. Sir, and
Anything
one more
else?
in convolution, actually you have took some two cases, right, sir? The signal will be continuing, right, sir?
It is continuing generated to check with respect to their limits.
Okay.
With respect to limits of individual signals, I have explained that. That is the reason I split it up. Otherwise, overall signal final output graph is continuous only.
Okay,
Hello?
the signal will be continuous.
Hey, brother, next slide only you see. Output is there. This rough graph I have done, it is not continuous starting from 4. Of course, it is not origin starting from 4.
Yes, sir.
Continuous only.
Okay, sir. Got it.
Hello.
Yes, sir. Got it, sir. Thank you,
Okay,
sir.
enjoy, sir. Right. Yes. Yes, sir. Sir.
Hello, sir.
Sir,
Sir, am I audible?
audible, audible.
Sir, my doubt is in shifting property, sir.
Okay.
Sir, I didn't understand the shifting property.
What is there to understand? This is a
Means,
formula I
sir,
derived. This is the formula I have derived. How I derived? If my input is delay, output is impulse response function. What is time systems are? A delay in the input signal causes same delay in the output signal. I have delayed by k samples, output delayed. I have done scaling x k से multiply किया. यहाँ पे भी x k से multiply होता. Summation ले आता क्या था? Summation ले आता additive बोलते. Whatever this expression we got, shifting property बोलते हम. Okay?
Yeah.
In our
Yes, sir.
example, how to understand this property? How to understand this property is with this example. So here I have taken example sample from -1 to 2. According to our derivation summation, there is a background noise here. Brother, I'm getting so
Yes,
much
sir.
background noise here. Here summation varies from -infinity to infinity. In our example, summation varies
Yes,
from
sir.
-1 to 2. This explanation I have given here.
Yes, sir. Yes, sir. Yeah, I understand. I understand. Thank you, sir.
Right.
Hello, sir.
Uh,
Sir,
Hello, sir.
48 F.
one by one.
48 F, sir.
48. Tell me.
Sir, in this x of n and x of n minus 3, if we take n is equal to 3, then we'll get 1, no, sir?
Amma. What invertibility definition, ma? Tell me. Different inputs having different amplitudes. Why you are substituting index? What is the statement I have made for invertibility? Different inputs with different amplitude. Why you want to substitute the index n plus 3? You want to tell me? We are looking for amplitude or time?
I mean, you are multiplying. Sir. You are multiplying.
What I am multiplying? I am multiplying amplitudes only. I am multiplying amplitudes only. Del n amplitude 1, del of n3 amplitude also one, product is 0. 1 into 1, there is no overlap, 0. Hello?
Sir, we should not substitute n is equal to 3, sir. In y of n.
Hey, when you are repeating the same question, why you will substitute n plus 3, ma? I did not understand. When you are checking invertibility, also output amplitude versus input amplitude is the graph. From where you will get instant. N plus 3 means that is time instant, na? But output, what is invertibility of a system graph? That is also y-axis output amplitude, x-axis input amplitude only.
Sir.
X-axis x of n, it is n. X-axis x of n, not n.
Okay, sir. Sir,
Is
in
this?
understood, sir. Sir, in conversion, why we are doing folding, sir?
I have given reason. Na? Folding is needed to provide. Suppose we transmitted some signal. Some system has to detect that. Suppose aeroplane contains a cockpit and some other systems. Matched filter also in aeroplane it is there. They have to detect the signal. So in the process of noise, background noise, how they can detect the signal means first the signal with certain amount of delay is shifted. That explanation I'll give in correlation, autocorrelation, cross correlation, not now. Just I said why folding is needed means in the noise environment to detect the signal we need it. Okay?
Okay, sir. That's it.
Who is next?
Sir, on page 37F.
One sir, 30?
7F.
1 minute. Yes. Sir.
Sir, in this example, x of n is we get the for negative value we get the y of n depends on the future input.
Which example you are saying? This one, this one, this one.
So this one, first one
This
on
one
this
is
side.
first
X
one.
of k. This one.
Left side.
Yes, sir.
Tell me, sir.
So for this example, for the negative value, we are getting it depends on the future.
Future sample, sir. Yes.
And for positive value,
obeyed. But whenever you take general n, he will is causal for n greater than or equals to 0, non-causal for n less than 0. Any general index, maybe for positive index here it is satisfied, negative index failed. Okay. So positive index it is satisfied, negative index it is failed means overall non-causal. Tell me.
You are not wrong. Sir, can we say that this system is non-causal for n less than 0 and causal for n greater?
That's what it, because it is a general system, we should not say that way. N is general. If it is n naught, you can say that way. In general, n for positive index it is obeyed, negative index failed.
Okay.
Where?
And sir, one more doubt on 48. On 48.
48,
40. 40.
Tell me, sir.
Sir, not this previous one. This one. Sir, suppose on the right side. Sir, suppose the signal is not rectangular. Suppose other signal given. Then how to solve this example?
Let me give idea. Suppose I have given ramp as the expression 0 to 3. So to convert, listen. To convert rectangle to ramp, we may need integration. Tell me.
Yes.
Integrator is a static element or memory element? Storage. Integration means storage or not?
Yes.
Then it is dynamic only.
Sir, you are giving the standard signal. Suppose if I solve this, if I find the equation for x of t and y of t, and then
do one thing. Not if but. If you have any specific questions, send me. I will tell you the answer. Not if or but.
Okay, sir.
Okay.
Okay.
Right.
Hello, sir. Sir, page number 60, sir.
Page number 60. 1 minute to. Well, I don't like to teach in the evening, but time has made like that. Yes, sir. Bolo.
Sir, actually, we have taken the signals which are extending till infinite, no, sir, in time limit. Actually, my small doubt is nothing but here in case 2, we are taking it is from range 0 to t minus 4, no, sir. Are we neglecting?
This is done with respect to which variable, sir?
Yes, sir, that one I understood, sir. Here, are we neglecting the lower amplitudes?
No, amplitude nahi hai. Finally, you draw the graph. This is the output expression we got now. If you draw the graph, something like this. This is output graph, which is YT versus T. This is YT versus T final graph.
Yeah.
Okay.
I got confused because we converted that into tau, no, sir. I mean, the time domain again we shift.
Integration is done with respect to tau. Yeah. Integration
yes, sir,
is of course done with respect. Enjoy.
Thank you, sir.
Sir.
Hello. Sir, in page number 40F.
1 minute now. 40. Yes.
Can you explain the causal one, sir?
Before application of input, output should not occur. Where I started rectangle here at 0, na?
Yes, sir.
Output also started at 0. Even it started 1 also, no problem. Suppose if I have taken output rectangle starting at -1, I have given input at 0, output starts at -1 means meaningless, non-causal.
That means input is ahead of output.
If I apply input at 0, output should start at 0 or greater than 0. That is causality condition.
Yes, sir.
Okay, sir. Sir, in yesterday's problem, the third one, full wave rectifier, that average is 1 by t integral 0 to t x of t dt. That integral t is t naught and 1 by t is t naught, sir. Both are t naught.
T means T naught only. T means T naught only. That is anyway periodic signal at T naught only.
Then if I'm getting 2 by pi, sir, instead of 1 by pi.
You take signal as sin pi t by 2. If you take sin pi t, it is wrong.
The whole time period I should take it as 2 only, no,
It is
sir?
2 only, but it is full wave rectified, which is actually generated due to half wave rectifier passed through non-linear device like mod x. So it's originally it is sin pi t by 2, not sin pi t. Sin pi t by 2, time period is 2 only.
Okay, sir.
You take xt as sin pi t by 2.
1 by t is also 2 only, no, sir? 1 by.
That is 2 only.
Okay, sir. Okay. Sir, is convolution applicable only for linear in time invariant or any system, sir?
LTI system only. What is a black box itself is LTI system. Na?
So we cannot apply this convolution to any other system.
Non-linear systems you cannot apply.
Okay, sir. Thank you, sir.
Next. Who is next?
Hello. Sir, I have doubt in 43F, sir.
43.
Sir, that sentence, sir. If input derivative is more than the output derivative, system is unstable.
See, d by dt xt means what is the order of derivative for input? First order.
Yes, sir.
Y of t, no derivative, zero. No derivative. Just yt I have given.
Yes, sir.
So if input derivative, this is first derivative, this is zero derivative. If input derivative is more than output derivative in any differential equation, system is unstable. Suppose if I have given here d square by dt square of xt, then also unstable. In any differential equation, if input derivative greater than output derivative, system is unstable 100%.
Okay. Reverse can't be true, no, sir, then?
Huh?
Okay, sir, understood.
Enjoy. Next. Sir.
Hello, good evening, sir.
Yes, ma.
Yeah, sir, page number 38, sir.
Yes, ma.
Yeah, sir, can you please explain it again, sir? Because my network has gone, so I didn't hear.
వచ్చింది అడిగిన ఓవర్ యాక్షన్ చేయకు అందుకనే డోర్ పెట్టుకుంటా.
Who is that Telugu? Excellent Telugu explanation. నేను కూడా మాట్లాడతా కానీ సైలెంట్ ఉంటానమ్మా. Yes. What complete
Yes,
page? Okay. Whenever the present output is depending on what is condition for causality, ma present output should depend on present input and past input or past output. In this example, present output depends on past output as well as present input, so it is causal. So non-causal systems we cannot design practically, but there is a technique to convert non-causal to causal. One example I have taken here like this. If I have samples from -3 to +3, means it is non-causal. If I cascade minimum 3 or 4 delays, here I cascaded minimum 3 delays. Automatically it will cause right shift of 3 samples. Na? -3 to 3 means +3 is added. So what is a new index? 0 to 6. Na? Once you take data from 0 to 6, it becomes causal or not. So to convert non-causal system to causal system, one technique is time shifting operation. Then I have made conclusion. Causal system means present output must be a function of which combination? Present input xn, all past inputs as well as past outputs. That itself. Hello? Hello? Hello?
Hello, good evening, sir.
Tell me, sir.
45 page.
Huh.
45.
Yes, sir.
Sir, the right sided one I didn't. Right sided one.
Ilma, what is your doubt?
Sir, on the right sided slide.
What is the doubt?
Sir, here we take in n, sir. For Bibo means it's dependent on the x of n and y of n, sir. But there is no.
Correct only. This is output graph na. I have drawn output graph by taking a bounded input. I applied input with an amplitude of 1 only, which is finite, but I got output as which graph? Ramp.
So it does
Because
not
of
depend
giving
on the
this
time,
input,
na,
I
sir.
got out-
It should not depend on time, na, sir.
See, ma. Okay. Show the output is n. Leave the graph. Output is n.
Yes, sir.
What is the meaning of n? RAM sequence. RAM sequence is bounded or unbounded?
Unbounded, sir.
Unbounded. But what is target? Even you cover infinite time, output amplitude must be finite or not. Suppose if you take step function, even at infinite time I have amplitude of 1.
Yes, sir.
If you take step function, but RAM sequence at infinite time its amplitude is infinity.
Yes, sir.
Means for all time it is not finite. For all time it is not finite. I have given bounded input, but I got unbounded output.
Okay, sir. Sir, in invertible, you are taking sometimes step function, sometimes you are taking impulse. How we can know that, sir, in exam?
Not sometimes. If it is failing for, if it is obeying for u of t only, next combination I am going. If it is failed for ut, I am leaving there only. See, this example ut minus ut failed. To give one more example, I have taken this. Anywhere ut signal obeyed means then only I am going for next combination like the last one. Last example which I have given, what I have done here, ut minus ut, as it is obeyed, I have done for some more signals.
So we can give standard signals, sir.
All standard signals.
Okay.
It's not according to your convenience. For every standard signal, we should obey it.
Okay, sir. Thank you,
Okay.
sir.
Okay, next. Bhavan.
Hello,
Okay.
sir.
Ah,
Sir, can you go to 123F?
123.
123.
Is 123?
Actually, yesterday you have given one question that a signal consists of periodic alternative sequence for
4
values.
4 minutes. Bolo.
4 minus 2, 4 minus 2.
Bolo.
So we will take only one period, right? In that question.
One period is just 2 samples.
Just 2 sample we will take, right? Okay. And one more doubt is in 99F. Can you go to 99F?
Where is 99? Yeah, today I am using new slides.
Okay. Actually, that 3 questions you have given, na, the full wave rectifier. The third signal.
Third signal क्या है?
The third signal, the power. What is the answer of that power? I just
Whatever the number I have given you, that answer is same. You ask from your friends or anyway, it is the slides are uploaded now. Just look there.
Sir, can you
please.
do that?
I
I'm
will not
just
do. I
getting
will
a
not do.
different.
That shape is combination of rectangle and triangle. Before it also you
Yes.
can put the model. So
Yes,
what
yes.
you have to
So-
do, rectangle plus triangle whole square means
2AB
rectangular
we
per energy,
also will do
triangular
that.
per energy 2 times area under product
Yeah.
of rectangle.
Yes. Also divided by fundamental period. Will do.
Yes, 100% you will get that number, whatever I have given.
So I'm getting different answers, so that's why I just got confused.
Yeah, you send me in WhatsApp because that slides are not there with me. Let me see.
Okay. I'll send. Thank you.
Next. Next. Hello. Elma.
Hello, sir. 59 slides, sir.
59 only.
This only. Yes,
I'm at
this
59
only.
only.
In multiplication, the case 1 and 2, I didn't understand, sir. Could you please explain once again?
What ma?
This case 1 and case 2, sir.
Why I'm taking? You have not understood.
Yeah. Yes, sir.
Our target here is what? We have to slide one signal on the other signal. I kept x of tau signal as it is, na? On this x of tau, we have to move the signal h of t minus 2 or not. Then only we'll get to overlap. In that process, what is the upper limit of the signal, ma? T minus 4. What is the lower limit of other signal? 0. So first case I am assuming the shifted signal has not entered other signal, means t minus 4 less than 0 means no overlap. I did not get any overlap. So next case what I have done, I want to enter into positive zone, means on the signal x2 I want to enter 0 to infinity, I can enter anywhere. So I have taken t minus 4 greater than 0. For some portion we got overlap. This is the output graph.
Okay, sir. Thank you, sir.
Okay. Krishna Vamsidhara. Who is that? Yes. Hello. 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 Arey. Harshavardhan. Another. Yes. He is speaking. Krishna Vamsidhar. Are you there? Where the? Not for he raised the hand. Only one fellow has raised their hand. I think he is not there. Okay, I'm leaving.
ಬಂದ್ಬಿಟ್ರೆ ಮತ್ತೆ ಏನಾಗ್ತಿತ್ತು ಗೊತ್ತಿಲ್ಲ ಅದು.
Yes, sir.
ಆಯ್ತು ಅಷ್ಟೇ ಅವಳು ಸುಮ್ಕೆ.
Who is that? Who is that speaking? Good to hear. Hello.
ಇದು ಸರ್ ಬಿಟ್ಟಮ್ಮ ಫಿಕ್ಸ್ ಮಾಡಲ್ಲ ಬಿಟ್ಟು ಒಂದೇ ಫೋನ್ ನಾನು ಕರ್ಕೊಂಡು
అది అసలు పేర్చుకోడు తెలుసా ఆల్రెడీ పెట్టుకుంటే బెటర్ నాన్న.
Hello, sir. Hello.
నా పేరు ఎదుగుతుందని అడగదాన్ని.
వేరే ఇచ్చారు మరి ఏం చేయరండి పేర్లు 4000 కూడా
Hello.
Hello, sir.
1 minute. 1 minute. 1 minute. Helma.
Sir,
Yeah.
you told us, sir, x of t equal to sin pi t by 2. That I'm getting 0, sir. When I take sin pi t, I'm getting correct answer, sir.
Sin of pi t by 2.
Yes, sir. Then minus cos pi t by pi, no, sir. Integration.
Minus cos pi t.
By pi. Integration.
Pi t by 2 by pi by 2. Sin pi t by 2 you take minus cos pi t by 2 divided by pi by 2. After that you substitute the limits.
Oh, sin pi t by 2.
Internally, not half sin pi t. Sin half pi t by 2. Within
Yes,
bracket
sir,
pi t by 2.
Yes. I'm not able to see board, sir. I don't know.
I have closed. I am not writing anything. I am about to close.
Yes, sir. I took like sin pi t total divided by 2.
One mass sin half within brackets pi t by 2 you take one.
Yes.
కావాలి అసలు ఏం
ఖర్చు
Right.